I'm very happy to welcome to the workshop Spoke 5 within the FAIR project. And this is a workshop which we have invited all the people that who are doing research with us. And we'll see in a while that our family is expanded because we have new partners coming from grants and cascade calls. And so the idea of this workshop today and tomorrow is just to have a very quick overview of what we are doing during this talk. It's impossible to present everything because we have at this moment, I think around 100 researchers in total who are working in collaboration with the Spoke 5, and each researcher is doing amazing research, and many papers have been published. Of course, it's very difficult to summarize all this research and all the achievements, and so the idea is to have an overview and to give opportunity to some researchers to do the presentations in the sessions that will be this morning, this afternoon, and tomorrow morning. So today we start with a very brief overview of results that have been obtained during the project. So I will give numbers about KPIs. Very boring. But then we will have, I think, an interesting panel with work package leaders or work package representatives, just to comment what have been the best achievements that we are presenting recently. And then we will have the three sessions that I will describe in a while. And thanks also for participating here, of course, in presence at the Romagna, and there are also people connected remotely. Okay, so just to summarize, this is the slide that has been presented also in previous events with the partners who started to be involved in Spoke 5 since the beginning, with the 6 departments from Sapienza and 3 institutes from CNR. And these are the numbers of people. But then, as mentioned, I'm very happy that the family enlarged with affiliated partners. And we have 2 companies that are part of the FAIR companies through innovation grants, and we'll have in these days presentations about their projects. We have some new universities that have been funded through the academic cascade call, and Verona, Brescia, Bolzano, Roma 3, Tor Vergata, L'Aquila, and Padova. And we will have very, very soon additional 5 companies that will be funded through the industrial cascade calls. And so this will complete the picture of the overall partners and affiliated to Spoke 5. And all these researchers will do some research in collaboration with people from Spoke 5. And the idea is to have collaborative research, collaborative projects that will enable additional results. And most of them will, I would say all of them, will give a presentation during one of the next sessions, so they can illustrate already some results that have been achieved from these projects. Okay, very quick recap about what is the main perspective and goal of Spoke 5. The high-quality AI means the focus on developing AI systems with high-quality requirements and standards. And we really focus on methods that can measure qualities of the techniques that we implement in our systems that can be formally measured, and we can guarantee some formal properties. And this is very important because want to increase, of course, trustworthiness of AI, usability, and acceptability. In particular, adjustable autonomy and measuring the quality of AI and base the autonomy of AI on this quality is also very important. So we think of systems that can understand when it is the right moment to increase, for example, its autonomy, and where is the right moment to decrease the autonomy and give control back to human. And this concept is, let's say, applied to all the subfields of AI, including perception, actuation, learning, planning, reasoning, and so on. So you will see in the presentations that all the main sub-disciplines of AI have been addressed in our spoke. So we are organized in 7 technical work packages and 1 work package that is oriented to pilots and case studies. And you will see most of the presentations, the scientific presentations coming from the 7 work packages. In particular, as mentioned in the panel that will start in a few minutes, we will have the WUP leaders or WUP representatives that will illustrate the main achievements of each work package. So I will not describe at this moment the details because we'll have the panel in a while. But you can read the titles of the work packages to see that in Spoke 5 we embrace all the most important sub-disciplines of AI. Work package 5.8 is a particular work package in which instead we aim at collaborative projects, in particular with companies and industries, to showcase the techniques that we develop in our spoke through pilots and case studies. Okay, I want to recap very quickly some scientific events and meetings that we organized during this year. So starting from the workshop that we had last year. And you can see that Spoke has been very active in organizing scientific events, including workshops at international conferences, for example, at ECAI or at the AI let's say in Italian conference, but also there have been many activities already with academic cascade call, the kickoff meeting, and some scientific meetings that have been organized in this setting. Moreover, you know that the FAIR project includes some transversal projects that are projects that span over several spokes of FAIR, and the responsible in Spoke 5 of these transversal projects organized many workshops and events. And you can see here, in particular, transversal project 2, 7, and 4 that have been active in organizing events. This is important because, as mentioned, we really want to do research together within FAIR. Okay, now very few slides about KPIs. The overview is that I would say that we are very well placed. And so, you know, the project will end in December. So, but for most of the KPI, we already reached the targets. In some cases, we exceeded this target already. In particular, about scientific publications, we are largely over the targets. We are doing very well. About algorithms, datasets, and benchmark, I would say that we are in schedule. For some KPIs, we already reached the target. For some other, we are in schedule. So we have we will focus more in this third year of the project to complete this activity. Same for use case pilots and industrial collaborations. This was planned to be mostly in the third year of the project. And as mentioned, now with the 5 industrial projects that will start soon, we will cover also these KPIs. About the dissemination events, most of the targets have been already reached, and of course, we have space to complete this during this third year. And about cascade calls and industrial involvement, again, the process is ongoing, and the most effort was planned for the third year. So we are very confident that we will meet and largely exceed at the end all the KPIs. So for this, I'm very happy, and I have to thank all of you to contribute to this result. Now, I'm going a little bit more in details, not for every KPI, but just to give some numbers that are, I think, very relevant. So in total, we counted this number of publications, scientific publications, over 250. And it's important also the high quality of these publications. So we have 36 Q1 journal and 553 first-class conferences in total. That is, of course, a very nice result. And here there is also a link to all the publication of the spoker. It is a document with many pages. So thanks again, all of you, for contributing to this. And about some specific KPIs, for example, articles in AI venues will acknowledge to FAIR. You see that the target for the end of the project was 71, and we already have 118. So we are above already above the threshold. And we have published in all the top conferences and top journals. This is, of course, very important to see that FAIR, and in particular SPOC 5, is very well represented in all the top AI conferences and journals. Let me mention some outstanding achievements. A Distinguished Paper Award at EJKI 2024. And I think it's very important. There will be a presentation about it in this afternoon. And this is something that which we are very proud to have a FAIR acknowledged paper as a Distinguished Paper Award. EJKI is the best, or one of the best conferences in AI, and outstanding paper awards in the field of NLP also. This is they are very important, and these papers have been reached some really outstanding achievements. Of course, they will have a very high impact also in the future. About multidisciplinary articles, so we are not publishing only in AI venues, but also thanks to collaboration with other departments that are, we have many multidisciplinary activities. And here I think that we have been, when we set the target KPIs for this, we were maybe very pessimistic because we put only 19 papers as target, while we already reached 69. So it means that our process of publishing AI papers in other fields is, our effort has been very, very good. And here you see some examples of conferences and journals. Also, you can see numbers that will increase for sure, because we already have, for example, in this category, 22 papers that have been accepted and not yet published. So by the end of the year, we'll have also this other number of papers that will increase the total. About papers with interspoke and intraspoke authorship, this is very important. One of the main goals of FAIR is to foster collaboration among researchers, in particular new collaborations. And so here we already have, I would say, reached also this target. At this moment, we have about number of articles with interspoke authorship. We are 14 out of 15, but 5 papers have been already accepted. So we will meet this target very soon. And the same for articles with the interspoke alloship in the transversal projects. So this is very important to have more and more collaboration with others. And about the algorithms, datasets, and benchmarkings, so we are very good in all the KPIs that are related to algorithms and systems that have been made open available. And so also here we were very cautious to have as target 8. We already reached the 28, so this is not a big problem. In terms of benchmark datasets, we are still working on it. So the idea is that in the third year we will have more publication of benchmarks and datasets in order to reach the target that is 18. And same for use case and pilots. So we reached the target about use case and pilots with focus on human AI and with focus on robust and trustworthy AI. We are still behind the target for the joint industrial use case and pilots, but as mentioned, 5 projects will start soon, so we will reach this target very soon. Okay, let me just mention some again, notable examples. In this case of system that has been released, it's, I would say, very successful. That is Minerva LLM, and this will be described also this afternoon in one of the presentations. And here we already have a very high impact. You can see from numbers like hundreds of thousands of downloads and thousands of users that interacted with the system. And this has been released just a few months ago. So I think the impact of this system is also very nice and very important. And another example of benchmarking activities, a large-scale dataset for SLAM that has been released also a few months ago. And here what is very nice is the possibility of using the system to have an automatic evaluation and a leaderboard. So it is possible for researchers to compare their methods and to have to see a ranking of the measures that have been implemented for measuring the quality of this kind of systems. Okay, finally, KPIs on events. And also here, most of the targets have been already reached, but of course, in the third year, we want to do more. Dissemination is, as you can imagine and understand, is a very important goal for a research project like ours. And I think that we already did a very good job in dissemination. Here you see some numbers of the KPIs, and of course, we will do more in this third year, so that not only we are doing very good research that is very well recognized in the scientific community, but we are also addressing, of course, general public and also industrial partners. Okay, so this is a quick overview to say that we are doing very well. And again, thank you for your contributions. Now, what we will proceed today is in this first session with a panel with VP leaders or VP representatives that will give a little bit of details about the main achievements that have been achieved in each work package. Then we have a coffee break that will be upstairs in room 203, that is exactly upstairs from here. And we will continue this session today with autonomous agents and physical embodiment with Elena Umili, will be the chair. Then we'll have a lunch again in the room above. And in the afternoon, we'll have a session on data quality and generative AI that will be chaired by Federico Scafolieri. And then tomorrow, we'll have a session at 9 about quality in machine learning, chaired by Annalivia Croella, a coffee break at 11, and then a final session with conclusions fusion wrap up, and again a lunch. So this is the program of this 2 days workshop. Okay, so if there are no questions or no additional comments, and this part was quite quick, and so maybe we can start with the panel. I would like to invite Fabio, Riccardo, myself, Roberto, Elena, Jacopo, Fabrizio, and Giorgio, and we can have the panel starting in a few minutes. Adesso in piedi perché non avevi sedia certamente. In ordine sparso. Okay, thanks. We will start a few minutes, so you have a little bit more, but we have 3 questions here, many, so I will invite you to be very short. As mentioned, here we will just highlight some best results, then there will be specific presentations on some of the works that have been in the work packages. Okay, so we will start asking each of the VP represented to discuss a little bit, to give an overview in 2 minutes about what are the most important scientific achievements in the work package. And magically, we have some slides for it. And so we will start in the order in which slides appear. And so I will give the word to Fabio first to answer the question about work package 5.1. Thanks.
Okay, good morning. Okay, so this is about WP 5.1, which is on scientific foundations for adjustable autonomy. As Luca mentioned, we have a large body of work on all these topics, so it's really hard to pinpoint one work or possibly the best work. So I would say that in general, the overall achievement of the joint effort we are doing in the WP is establishing logics as a central means for verifiable adjustable autonomy. And in particular, we have in many works, we have showed an effective use of these logical approaches. We have used logics for modeling critical features in the context of adjustable autonomy. And these are, for instance, safety, acceptability by humans, and ethics. Techniques have been used for enforcing these features while maximizing autonomy, which means that the system is asked to perform autonomously tasks while possibly resorting to the help of humans, but minimizing these help. And then we have used, these are all different works, this approach for managing the intentions of an agent. Now, just to mention one, which is the most recent, and I think it's an important work because it's in collaboration with a partner from the academic Cascade Call. I just mentioned this work, which is about a shielded fund that has been published at ICAI 24 in collaboration with Brescia. But besides, we are not only focusing on exact approaches, logic-based, but we are also combining these approaches with machine learning. And in particular, with deep reinforcement learning to deal with non-Markovian goals, non-Markovian rewards, which are rewards that do not depend on the state only, but on entire trajectories of the system. And this will be discussed later in a coming talk following this panel, in the session that will follow this panel. I think I stayed within the minutes. Thank you.
Thank you. Okay, so let's move to Riccardo for work package 5.2.
Okay, so good morning. So I'm Riccardo Rosati, and I'm speaking in the name of Maurizio Lenzerini, who is the real work package leader of this work package, which is on data quality for data-centric AI. So we have actually a lot of results for the main results. We can say that in this work package, we are essentially studying three main directions. The first one is on data quality approaches, and in particular, we are focusing on the problem of entity reconciliation in these approaches. And actually, there are a good number of contributions that our group has provided in this direction. I'm not mentioning this topic further because there is no time, unfortunately, so I will focus on the next two topics. The first one is reasoning on knowledge graphs. We are also contributing in this field, in this area, and we are specifically proposing or focusing on the idea of finding a unified logic-based foundation for knowledge graphs, because knowledge graphs appear central in or very important for neurosymbolic AI approaches, which is one of the ultimate goals of our research. However, this approach to knowledge graphs still lacks foundations. In particular, we are interested in finding or proposing a form of logical foundation for knowledge graphs, because the various approaches are based on different interpretations of the meaning of knowledge graphs. And in particular, we are studying on integrating reasoning and meta-reasoning on knowledge graphs with queries that are able to both retrieve knowledge at the objective level and at the meta level in these graphs. Also, we are focusing on queries for quality checking over knowledge graphs. Finally, I mentioned the third area, which we are actively working on, and which is privacy-preserving query answering on database and knowledge bases. And in particular, we are focusing again on a logical approach to this problem. We are mostly focusing on a problem that is called, an approach that is called control query evaluation. This is the topic of the paper that was mentioned by Luca in the initial presentation that got the Distinguished Paper Award at IGK, and the paper will be presented this afternoon by Lorenzo Marconi, so I'm not giving you most of the details of this because you will see this in the afternoon. Thank you.
Thanks. I will speak for package 5.3. Also here, there has been a lot of research, but I choose to focus on one particular topic. That is the integration of generative AI and the social or industrial robots. That I believe is very important. It's, of course, a very hot topic, and is addressing the problem of understanding what happens when we give a body to a generative AI model. And so in this area, we are doing some research. Some of them has been already published or submitted, and some other work is in progress. And I list here just some examples of this kind of combination that is about, for example, generating robot plans using LLMs, or combining LLMs with symbolic reasoning. In general, we believe that we can exploit what we can consider a common sense knowledge that is inside an LLM to improve the ability of AI agents, and in particular robots or social robots, to interact with the environment, but also and in particular with people. For example, in a human AI reinforcement learning, so if you want to train an AI agent through reinforcement learning to do some interactions with human, there is always a very big limitation that is given by the fact that you cannot ask a human to, I don't know, play against an AI reinforcement learning agent for thousands or millions of iterations. And so one experiment that we are addressing is how to use LLMs to generate agents that resemble human behaviors that can be used to train AI agents through reinforcement learning. And this is very interesting because LLMs contains some information about how, in general, humans will behave in some conditions, in some situations, and they can be very helpful, for example, as sparring partners for the reinforcement learning agents. And also, this is a very important topic we discussed a lot also with the industrial robotics community. They really would like to have what they call the narrow language robot programming. So not anymore that you have to write code in C++, ROS, Python, whatever, but you want to tell the robot what to do. And this is, we believe that may have a very high impact also in industrial robotics, now especially with Industry 5.0, in which industry wants very flexible machines and flexible robots. But to have flexible robots, you need also flexibility of interacting with this robot in other languages. So we believe that another language robot programming will be a very important topic for next developments. Okay, and so that's it for WP 5.3, and I leave the word to Roberto for 5.4.
Thank you. Yes, so the work on work package 5.4 was on the quality assessment in natural language generation. It's clearly a trendy topic because you know, everybody in NLP is now focused on the generation side, which I don't totally subscribe to. And that's why actually we have been working on a lot of research in the direction of grounding what is generated to existing knowledge bases, multilingual knowledge bases. And so that's where we came up with, for the first time, with a very large open text semantically annotated corpus, annotated in multiple layers, starting from the word level or sense disambiguation, then moving on to the sentence level, semantic role labeling, semantic parsing, relation extraction, all of this done automatically, of course, because it's very large scale, but with guarantees of quality. And so that also allows for the first time to create systems that, semantic systems that can associate explicit meaning with words, sentences, at scale and multilingually. And so then we also continued work in this direction by innovating the task for word sense disambiguation with the word sense linking task, which also addresses the issue of identifying the candidates, and the semantic role labeling task, which was mostly focused on verbs as the driving phrases, driving words that would govern the meaning meaning of a sentence, expanding it to nouns, because of course there are many nouns that can play the role of predicates in a sentence. And so now we have a unified approach that can perform semantic role labeling, identify the predicates, identify the arguments, multilingually and across parts of speech, so nouns and verbs. Then we also focused on the issue of safety, bias, and fairness. This is in the context of the Minerva LLM, where we made considerable work in terms of identifying the various types of bias, the various types of sensitive information that can be used, written, produced by a model. But we're also currently working on identifying bias in Wikipedia, discrimination bias and political bias. So this is to address an issue that is clearly important. There was a recent conference in Paris on AI on safety and ethics, safe and ethical AI. And the last 2 points are actually interconnected because we aimed to address the issues of hallucinations. And hallucinations are all over the place in LLMs. And in order to make sure that a hallucination is produced, we need, again, grounding. So what we did was to put forward a framework, DBMT, called, it's an acronym for disambiguation bias in machine translation, where we are able to determine the ability of a machine translation system, which nowadays is generative, so it's an LLM basically, to identify the correct translation for an ambiguous word in context. And the problem, what we found is that ambiguous words are correctly translated when they're using their predominant meanings, but incorrectly translated even by state-of-the-art MT systems when the meaning is non-predominant. And so this is a framework that now allows to identify the level of the capability of a system to understand the meaning of a word when it's not used in its frequent meaning. And we also identified issues in the current metrics for machine translation, the state-of-the-art ones that are used to evaluate systems. And so we worked at the meta level, so the meta evaluation of these metrics. And we also provided ways to make them more interpretable, so that if a metric retrieves a score, produces a score, then this score between 0 and 1, what does it mean? I mean, 0.8 for a score could be good, for another could be bad. And so we made these interpretable with work that we presented last year and more work that we just submitted. That's all. These are the main things I want to talk about.
Thank you. And we proceed with work package 5.5, Elena.
Okay, thank you. Good morning, everybody. I'm presenting work package 5, whose leader is Chiara Cammarota. And well, within this work package, we collected many results covering different contexts and application. And here I've chosen to present a result belonging to the research line dedicated to the application of statistical mechanics tools for the investigation of Hopfield-like neural networks. And our starting question is, can we design a suitable architecture to make the model able to achieve, to accomplish more challenging tasks with respect to the standard pattern reconstruction? And in particular, the question that we have in mind, the task that we have in mind is the possibility to give as input a mixture of pattern and receive as output each single patterns constituting the mixture. So to help in intuition, we are supplying something like a chord, and we want the machine to return each single note making up the chord. So to face this kind of problem, we designed a modular network as the one presented here. and where we introduce intra-layer and inter-layer interactions, which are of a Hebbian nature. And we were able to obtain an analytical picture of the behavior of this model. So calculations are very hard, but doable. And we could summarize the overall behavior in terms of a phase diagram. So we highlighted that the key control parameters are beta, which tunes the smoothness of the activation function, and lambda, which tunes the magnitude of interlayer interactions. And in between the two red lines, the machine can work as a disentangler. Admittedly, these analytical results were achieved in a controlled environment, which means that we have statistically controllable patterns. Specifically, they are Rademacher patterns, but we also checked numerically the robustness of this functionality, moving to a structured dataset made of digits. And here is an example. And this kind of functionality is now further studied towards applications in matrix factorization and feature extraction. Thank you.
Thank you. We can move to package 5.6, Jacopo.
All right, cool. So I am Jacopo Masi. I am part of work package 5.6, which is on engineering and scientific qualities. And this work package is led by Fabio Galasso. So in the work package, there is Fabio, the group of Emanuele Rodola, and my group. And the contribution of this work package is threefold. And we mainly work on computer vision, machine learning, and deep learning. So let's proceed with the first contribution that we believe it's very important. It's by the group of Rodola. And the idea here, if you can see, is trying to actually compose and merge neural models without training. Why this is important? Because now these models, they are becoming huge, very large in terms of number of parameters, and training it's very expensive if you think about energy consumption and so on. And what the group of Professor Rodola found is that you can actually take models that are already trained and in the latent space stitch them together, just recovering geometric transformation, which is like scale, rotation, and translation. So this is just one of his work that was published at Neolips 2023, but he is developing a full line of work that goes from zero-shot autoencoder stitching to model merging, right? So the idea is that we don't train, we just reuse all the models that we have in order to compose this model and save energy consumption. Then we move to the second contribution, which is from Professor Galasso. So here, actually, we are changing domain. And what they did is detecting anomalies in videos of human behaviors, okay? So how does this work? Usually when you think about generative AI, you think about the data domains are images, videos nowadays, and also text, NLP, and so on. But here he's actually training diffusion models where the input data is the skeleton of humans, right? So then he's generative AI means that you are learning a generative model, so he knows things that are likely to happen. And the approach can look at the past and also can basically tell you, okay, this probably pose, it's not likely to happen, and then raise an anomaly. So not only this is scientifically interesting, but it's also, it has impact at the industrial level. Then we move to the last contribution, which is from my side. So in this work, what we did, we don't propose a new algorithm, but we are trying to understand the way adversarial training works once you plug it in the training of neural networks. Here in particular, we focus on classifier, but we are expecting to move to LLMs. And what does it mean understanding? It means that we are taking this discriminative classifier, reinterpret it as a generative model using an energy-based model. And for example, we find things that are interesting that we can detect when overfitting happens by just looking at the training set. So we are trying to understand the dynamic of adversarial training. And then lastly, we also found that these discriminative classifiers that are robust, you can actually use them to generate data. So actually, if you see in the bottom part, some images of CIFAR slowly appear. So you can basically generate data from a classifier. Okay, so that's all. Thank you.
Thank you very much. And last but not least, would be 5-7, Fabrizio.
All right, thank you. I'm actually speaking instead of Stefano Leonardi, which is actually in New York, lucky him, and is the actual coordinator of the work package that is devoted mainly to study foundational problems related to transparency and trustworthiness of AI systems. And I've picked some of the works that we believe are representatives of the activities that have been conducted, have been done in this work package. The first one is a new RIPS paper on hypergraph sheaf neural networks, where sheaves are these algebraic geometry derived, let's say, structure that is very, very effective in learning and helping actually to learn better representations for hypergraphs, because they offer, let's say, some, let's say, data attached to both nodes and edges, and these data are learned through the process. And again, this is a paper published at New RIPS 2023. Then let's say, changing completely topic, this transparency in auctions. Auctions are at the core of, let's say, most of the monetization activities in web services like Google, Facebook, and other big players are using auctions to actually let people pay, let's say, pay for showing advertisements. And the way, and let's say, transparency, that is how much the knowledge about the information on, let's say, value, bids, and whatever, play a role on this process was not so well known. And this paper that has been published at Stock 2024 gives some bounds on the regrets, in this process. Then again, changing completely topic, a paper published by Anna Livia Croella et al. That is actually submitted at Elsevier, is working on the well-known and classical problem of clustering data points. And the goal there is to try to develop methods to reduce the gap, the optimality gap in clustering. And they developed a novel algorithm that is based on a novel heuristics using what they call anti-clustering problem at its very core to improve the bounds. And then, of course, nowadays everyone is talking about RAG, retrieval augmented generation, that incidentally has been created at FAIR, but a different FAIR. And these, in the paper that I'm showing there, that has been published at the last SIG-IR, we show what's the impact of noise in these systems, where noise in this case is injecting random tokens into the prompt. And surprisingly, we showed that if you add noise to the prompt, you actually improve the results of the RAG system, actually highlighting that maybe there is a lot of work to do on LLMs to actually make them work better. Well, this was published in July, and nowadays there are already follow-ups that show how to improve the LLM for this particular task, which is one of the fundamentals, especially in the like say in the future where everything, it looks like, will be agentic. So anyway, this is it. Thank you.
Thank you. So as mentioned, this was just a very quick overview. and more presentations in the next sessions will give details about it. Now, our goal as Spoke 5, but also the goal of the entire FAIR project is, of course, also to transfer the scientific results that have been obtained in the work packages. So, for example, the ones that you just listened to use cases, pilots, applications, and collaboration with companies, but also other academic partners. And so this is the main goal of work package 5.8. It is to study the way in which we can transfer these results to more practical applications. And here I would like to ask Giorgio, who is the leader of WP 5.8, to summarize objectives and expected results of the collaborative projects, including in particular innovation grants and the ones coming from the cascade calls. And also here we magically have some slides for it. Giorgio?
Yeah, all right. So hello. So everything seems to be on track from this point of view. We started 2 innovation grants, one which is we started 2 innovation grants, one which is EGAIB and the other one which is Yara, which I'm monitoring, and the first one is concerned with developing generative AI pipelines in the banking sector for the analysis of banking documents, and the second one, Yara, is a collaboration with Leonardo for the analysis of radar data using AI for understanding what radar data means. We also started recently, actually, cascade calls, which involve a bunch of universities with which actually we will have fruitful collaboration. I'm already talking with Padova now for seeing what we can do. And everything seems to be on track from this point of view. And concerning EGAIB Yara and some of the cascade calls, we will have talks in the remaining part of the workshop. So, I mean, not much to be said now, given that it will be redundant information. And concerning the industrial calls, they are about to start. We have 5 projects, and we are on track in a sense that we expect most of the activity to happen in the upcoming time, so in this last year. That's it.
Thanks. So, close to the mic.
Yes, there you go.
Okay. So, yes, the idea of this project is to have collaborations with the researchers in Spoke 5, and this will be now further discussed in the third question that I want to address to all the work packages. It is about contributions to collaborative projects. So, as mentioned, the main goal is to contribute, extend, transfer the knowledge of the research that has been developed within the work package with other activities. And to this, we are aiming at collaborative projects, including the innovation grants, the cascade calls, and so on. And so I would like to start again asking all the WP leaders or representatives to illustrate what is the WP contribution to these collaborative projects, and we'll go again in the numerical order of work packages starting from Fabio.
Okay, thank you, Luca. So we have 3 active collaborations in 3 contexts. I forgot to mention an intra-spoke collaboration, but I mean, it's there. So one is with Politecnico di Milano in the context of Transversal Project 4, which is a transversal project about adjustable autonomy and physical embodied intelligence, and this is also together with WP 5.3, and this is about reinforcement learning with a model, so model-based reinforcement learning in a multi-agent setting, and in particular, we are testing the approach on a specific problem, which is multi-agent pickup and delivery, which is a well-known problem, multi-agent problem that has been studied in several forms. But this is the first time that a model-based approach in reinforcement learning is adopted for that problem. And also in general, the approach is novel. Then there is another collaboration with the University of Naples. Here we have actually more than one work. I have reported only one, which is incentive design for rational agents. And it's about basically normating how agents behave by giving them certain incentive schemas. And this is in some sense it's also an intra-spoke collaboration because it's by different tasks. And finally, we are active on an academic cascade call project, which is together with the University of Brescia, about which you will hear in the forthcoming talks. And this is on the work on shielded font, and I think also on a larger topic, which you will hear about later. And yeah, there's also another intra-spoke collaboration, which I didn't report, which is about the problem of strategy repair, which is, I don't remember exactly the tasks, but it's by our department and the Department of Computer Science, both of which are involved in this WP. Thank you.
Thank you. Of course, all this collaboration will produce more scientific results. Okay, we can go on with Riccardo.
So our work package is on data quality, so our collaborations are actually around the data quality, the aspects of data quality in AI. So first of all, let me mention the collaboration with the Politecnico di Milano, which is both an intra-spoke collaboration, because we are both partners in the same spoke, and also collaboration within the TP7, the transversal project 7, which is on data quality infrastructures. And in particular, the collaboration is focusing on the defining life cycles for knowledge graphs, so ecosystems, which is an interesting aspect related to knowledge graphs, besides the semantic problems, the logical foundation problem that I was mentioning before. This is also interesting because knowledge graphs are not static objects. It's interesting to study their life cycle, how they are generated, how they can be maintained, updated, etc. So this is a work in this direction. And then we have the Cascade Projects collaboration that just started, by the way, because the projects have started in December. And we have two projects, ongoing projects. One is with the University of Bolzano on virtual knowledge graphs. So again, knowledge graphs, but a particular category of knowledge graphs, so-called virtual knowledge graphs. And then we have a second collaboration with a second Cascade project, which is called Endurance, whose focus is with the University of Roma 3, Brescia, and Brescia with its main focus is on data augmentation, which is another important aspect related to data quality. So we are working in both directions, and we also believe that this academic collaboration will lead to interesting results and research products very soon.
Thank you. About work package 5.3. So something has been already mentioned by Fabio, because this is, as mentioned, joint work with this work package and within the transversal project 4. So it's about combining hierarchical and model-based reinforcement learning for many tasks, including multi-agent, pickup and delivery, multi-UAV. And so we are addressing this topic also in the context of human AI reinforcement learning. And so this is, in my opinion, very important. This collaboration is very important because we are putting together a different experience and different expertise. And here you can also see that in several cases we already have papers submitted or published on these topics. And then, as you can see that in all these slides, the academic cascade calls are appearing. They have been started since a few months, but we already have active collaborations and in some cases joint work in progress with ideas of submitting papers very, very soon. So with the University of Brescia, it's been already mentioned the collaboration on the project about resilient plants. I also want to mention that with the University of Verona, that will also be presented at the end of this morning. We are collaborating for safe reinforcement learning and model-based reinforcement learning as well. And then we will have soon to speak with Padova to understand what's the best way of collaborating also for the use case that they are presenting in their project with the Cascade Call. And so I think it's very important to join expertise of different research groups to create new research topics and new research results. Okay, we can move to work package 5.4. Roberto?
Yeah, for the P5.4, we have in place several collaborations. One with several institutes of CNR, Istituto Linguistico Computazionale and ISTI, and also Babelscape, to work on vocabulary adaptation, which actually I didn't mention earlier, but it's another way of making LLMs more effective and efficient. And so this also brought to a paper that will be presented in NAPO in a few months. Then we have in place a collaboration with the University of Bologna and Fondazione Bruno Kessler, the groups of Toroni and Bernardo Vagnini. This is on improving the way LLMs are evaluated. There are several issues. In Italian in particular, there's a lack of data, and so there was already a lot of work last year, and there's ongoing work this year on creating a large wide coverage multitask benchmark that will make it possible to evaluate LLMs appropriately, not only in Italian, also multimodally. And another thing is which metrics we should use, because it's not necessarily that, I don't know, first token probability, for example, is the way to evaluate all models in a fair way. And so there's also work not only on the creation of the data, but also on identifying the best metrics to evaluate heterogeneous LLMs. There's also another collaboration ongoing with the University of Bologna on creating instruction tuning data sets in non-English languages. We're starting from a recent paper in order to improve this research and make it scalable to other languages. In particular, we're focusing on Italian now. And finally, as part of DP2, we are collaborating with Unimore and other universities on multimodal and multilingual representations of meaning, also integrated within what we hope will be the next generation LLM, VLM released later this year. That's it.
Thank you. And we move on with work package 5.5, Elena.
So in work package 5, we have several collaborations ongoing, which were fostered by the field project. In particular, I mentioned a collaboration with the University of Bologna, which is involved in Spoke 8. This collaboration is about heteroassociative neural networks and statistical mechanics investigation of these networks. The result that I discussed before belongs to this research line. Then I mentioned collaboration with the University of Pisa, involved in Spoke 1 and Scuola Normale. This collaboration is about the development of tools, mainly algebraic tools, for studying supervised and unsupervised Hebbian networks. And this kind of research will be discussed by Alberto Facchetti tomorrow in his talk. Then we have a collaboration with the University Bocconi, which is involved in Spoke 4. This collaboration is maintained by Matteo Negri, who in his talk tomorrow will discuss results stemming from this collaboration. In particular, these results are about associative memories for structured data sets. And finally, I mentioned an academic cascade call project with the University dell'Aquila. And this project refers to adaptive physics-informed neural networks in MPC loop to recharge a lithium-ion battery. And by the way, concerning physics-informed approaches, I should mention another talk tomorrow by Lorenzo Colantonio. Thank you.
Thank you. We proceed with work package 5.6. Jacopo?
All right, so cool. If you consider the threefold contribution that you have seen before, all of them, they have collaboration involved. So if you remember the model merging approach of Emanuele Rodolà, he actually developed some paper with Francesco Locatello, that is now an assistant professor at the Institute of Science and Technology in Austria. Before, Francesco was, I think, in AWS, so that's a collaboration with a foreign institute. Then, regarding the second contribution that I showed you by Galasso, Professor Galasso, he actually developed one of these methods to anomaly detection for human behavior in collaboration with Laura Taichet, that she was assistant professor at TUM, Technology University of Munich, but now she's in NVIDIA. She's leading a group in NVIDIA. So this kind of in between in this industry and academia. And then finally, the last part that I showed you on adversarial training and so on, we actually have an orthogonal collaboration that applies these techniques to imaging and computer graphics in collaboration with Professor Pellacini, that now he's in Modena and Reggio Emilia. Before, Professor Pellacini was in Sapienza, and now he's in Modena and Reggio Emilia. Okay. Yeah. Thank you.
Yes, you should count also the contribution of with the Yara project, because Indro is also collaborating with Leonardo for Yara project. So there is an additional item to add in this list. Fabio and Indro, they're collaborating with Leonardo in one of the innovation events. In addition to this, thanks. And now we give the word to Fabrizio for work package 5.7.
All right, thank you very much. Yeah, so we have several collaborations going on, and in particular, as you can read here, we have collaborations with the University of Siena, Milan, and Pisa. actually, there is one missing, which is ESTCNR from PISA as well, where we are collaborating with them. I mean, especially in the projects that I showed in the question before. Also, some of the projects that we are conducting at the moment are intraspoke with the work package led by Fabio Galasso, in particular with Professor Rodolà. We are working on the, let's say, development of task vectors that are, let's say, a continuation of the work that Jacopo showed a second ago. And then I would like also to mention that most of the work that has been done, especially as part of my group, has been done in collaboration with also external, let's say, partners like companies and universities, companies such as Meta and Google and Amazon, and universities such as University of Cambridge.
Okay, thanks. So we are very active also in this spreading the knowledge, but also involving other researchers within FAIR, but also outside FAIR to contribute with us. That's very good. So let me ask if there is any question from the audience, general question about our goals, objectives, and the results. Okay, I think that it's normal. You will have questions to the technical talks. Now, one very little change of schedule, because I've just been informed that coffee is late. There's a target KPI that we didn't meet to have coffee on time. And so they will set up everything for at 11. So I suggest to start the first session and to not delay. So if there is no, I think it's better we can start. Well, we can switch. So let's have one speaker who is available now, because otherwise we have to I mean, we need to anticipate, because coffee break will be at 11, and otherwise we will not meet the lunch deadline. That is something important. So I suggest to just anticipate a couple of talks, and then we'll have the coffee break, and then we'll continue. So I would like to invite Elena here to be the chair of the session. Yes, we will have 5 minutes, but not a coffee break, just a break here, just to switch set up. Then we'll have 2 talks now, then the coffee break, and then the remaining of this session. Thank you very much to all the speakers for the presentation.
Okay, we can start session 2. I give you some minutes to go in place. Okay. Okay, good morning. Thanks for being here. Now we start session 2 on autonomous agents and physical embodiments. The aim of this session is to introduce the progresses made in work package 5.1, 5.3, and in the transversal project 4. And we will see also some presentation from collaborative projects. So we will start with 3 talks from people of this department. Me, Nicola Scianca, and Simona Gossinelli. After that, we will have the coffee break. And after the coffee break, we will resume and we will have 3 presentations from other universities that won the academic scale calls. In particular, we will have the Intellecto project introduced by Professor Emanuele Menegatti from the University of Padova. The Behave project described by Alessandro Farinelli from University of Verona. And finally, we will close with a presentation on the Resilient Plants project from Alfonso Emilio Gerevini from University of Brescia. So, without any other delay, we can start with the first talk. I invite Nicola Scianca to be here on the stage. So Nicola is an RTDA here at this department, working mainly on work package 5.3, and the title of his presentation is a decentralized cooperative transportation scheme for humanoid robots. Okay, Nicola, the stage is yours.
Okay, thank you, and thank you to everyone who's here. So this talk is about a scheme for cooperative transportation that we proposed and we published in Humanoids 2024, which was presented in Nancy in France last year. And so I will start from just briefly presenting what's the problem that we would like to address with this work. So the goal is to design a scheme for cooperative transportation of large objects. So for example, think about something like a table or a large manufactured product. And in particular, we want to design something that is decentralized. So decentralized means essentially that if we have 2 robots collaborating, each of the robots should work autonomously. So it should decide by itself how to move. There should not be a centralized controller that tells both robots how they should move. The reason why we want to do something that is decentralized is because then we can use it both in robot-robot collaboration, but we can also use it in human-robot collaboration, because at the end of the day, we would like to make something that could be useful and could be helpful to, for example, for a human performing something like a heavy transportation work, and could aid and relieve some of the heavy work that must be performed. So we do this, but we still would like to test this on robot-robot collaboration. So in particular, in this kind of task, we will talk about two different roles within this transportation task. And one robot will have the role of the leader, which could be a human, but in our case, it would be another robot. And in particular, a robot that has knowledge of the tasks. So it knows where the robot should be, where the objects should be transported. The other robot is always going to be a robot, it's not going to be another human. And it's called the follower. And the characteristic of the follower is that it has no knowledge of the task. So this means that if at some point the leader starts moving, the follower should decide what to do just based on what it perceives. So if it feels a force pulling the object, it should react in such a way that it doesn't fall and that it collaborates in the transportation task. This is a general overview of the architecture. And without going into many of the details, because I will talk about them later, I just want to stress the fact that both robots have more or less the same architecture for control. The main difference is, you can see it's depicted in red, and it's essentially the way that the footstep plan is being decided. So on the left, where we have the leader, the footstep plan is essentially being informed by the knowledge of the task. So where we would like to bring the object. On the right, where we have the follower, the footstep plan is being decided online, and in particular, as I will explain later, will be decided based on the movement of the hands. The movement of the hands, which in turn is decided by a hand admittance controller. So let's begin from the hand admittance controller. The hand admittance controller essentially is in charge of giving the robot a position where to put the hands. And the idea is that we would like the hands to move in such a way that if a force is applied on the hand reacts as if it was a virtual spring mass damper system, so in a compliant way. So essentially, the dynamic equation that you see here is essentially just a virtual spring mass damper system that the dynamics of the hand should follow. And this compliance is on both sides. So it's both on the side of the leader and on the side of the follower, because there will be a lot of interaction, and we would like that the system, the transportation system, is compliant on both sides so that both the robot can absorb in unforeseen disturbances. And another thing that I would like to stress here is that the motion of the hands is completely 3D. So not only we can react to forces in the frontal direction and in the lateral direction, but we can also accommodate a change in height. So for example, if the robot is collaborating with a human and the human raises the object, this will also make the follower robot raise the hands in response. So the information about how the hands are being moved, which depends on the forces, is sent to the footstep planner. The footstep planner is different for both robots. So in particular, we said that on the leader, it's essentially given by the transportation task. But the follower is constantly generating footstep location, and it's generating footstep location with the idea they shouldn't fall. So we would like essentially the follower to follow the movement of the hands, because if the hand admittance controller is commanding the robot to move the hands in a particular direction, then the feet should also move in the same direction. And the way in particular in which we do this is we use an optimization problem. Why do we use an optimization problem? It's because we want to also enforce constraints on the position of the footsteps, in particular constraints on the footstep positions, so that the robot doesn't make a step that is too large and it's unfeasible, for example. But if there are obstacles in the environment, we also want to place constraints for avoiding the obstacle. And the final block of the architecture is the model predictive controller. So once we have decided how the hands should move and how the footsteps should be placed, now we want to generate a consistent motion for the center of mass of the robot. So this is most commonly done with model predictive control. Model predictive control is a control technique that uses optimization, and in particular, it optimizes the trajectory of the system over a prediction horizon. In particular, we use a simplified model of the dynamic, a simplified model that only involves the center of mass trajectory. And also the zero moment point. The zero moment point is a point on the ground that essentially encodes information about the contact forces, and putting constraints on the position of this point is very important to not have the robot fall. So the simplified model essentially looks something like this. As you can see, it's a it essentially tells you what happens to the dynamics of the center of mass, PC, in terms of the position of PZ, which is the ZMP, but there's also a term W, which is the effect of its external disturbances. And this is very important because external disturbances are essentially built into the scheme here because the robots are always pushing each other. So the MPC should not only plan a trajectory of center of mass that moves correctly, but also that correctly accounts for the disturbances. And the disturbances are being estimated by a disturbance observer. So the expression of the controller essentially is a optimization problem in which we have constraints on the ZMP, which are essentially constraints that make the contact forces feasible, and constraints on the stability of the system that are there to make sure that the trajectories don't diverge. And now I can show a video with a few demonstrations. So the first simulation is a transportation task of a 10-kilogram table. And here, essentially, the robot, the leader, which is on the left, is pulling the follower, and it's pulling it with a variable speed. So you might have seen that at some point the follower reacts to the change in speed and starts moving more slowly. Here we have not only changes in speed, but we have also changes in the direction of motion and also in the orientation. We have a mechanism for adapting the orientations of the footsteps of the follower also in such a way that it realigns with the orientation of the table. And at the end, you will also see that this also allows to generate a lateral motion. Here we have a similar task, but in which the transported object is not a table, it's a object with handles. The difference here is essentially that you don't have two separate contact locations, so it's more difficult to decide how the orientation should change. So we have a different mechanism for determining how the orientation should change in this case. And the last simulation is a movement in between obstacles. So there is an object in the middle that should be avoided. So the leader knows about that and raises the hands. The follower doesn't know about that, but it also raises the hands because the hand admittance controller is 3D. And then there is a cylinder in the path of the follower, which is being avoided by correctly placing the footsteps. So to conclude, the most important point about this scheme is that we can test it with robot-robot collaboration, but since it's decentralized, each robot is controlled independently, then we can deploy it with human robot in human robot scenarios. The way that the scheme is constructed makes it so that the robot will react with the movement of the hands if a force is applied, but then indirectly this will also trigger a movement of the footsteps in the same direction in which the force is applied. And as I showed in the examples, this can allow for a wide range of movements, in particular forward walking motion, lateral walking motion, diagonal, changes orientations, and even changing the height of the transported object. Okay, so that is all. Thank you so much for listening.
Thanks, Nicola, for the talk. Are there any questions from the audience? Luca?
Okay.
No, we actually did not think about putting the robot in a situation where there are two leaders. There's always a leader and a follower, and our idea was just to substitute the leader with a human. It would actually be interesting to see what happens if both parties would like to lead. Probably some behavior would emerge, but we haven't tried that. It would be interesting to, it would be interesting to test, yes.
Other questions? Yeah, I have a question. Basically, it's fully decentralized, right? So only the leader plans with respect to the task. And it may happen that they goes in a deadlock situation where they cannot move, because I imagine it plans only regarding the task and not considering the follower, because it is controlled.
This is something that we talked about. So for example, the idea was what happens if the follower stops for some reason, then it doesn't make sense that the leader should go on with the plan. And this, in fact, is not being taken into account now, but we would like to take into account. So the main idea would be to make also the leader be able to change its plan. So the idea was that the initial plan is just a suggestion that the leader should follow, but then if something happens, if the follower, for example, gets stuck because it has an obstacle it cannot get over, then the leader should, in fact, stop and allow the follower not to fall. Yes. I'm sure it would happen.
Okay, thanks again, Nicola. Okay, the next speaker will be Simone, that will give a presentation entitled Deductible Diaries in Robotic Process Automation with Trust.
Okay. Good morning, everyone. My name is Simone Agostinelli, and today I'm going to present you the main outcome of a Dutch tool seminar that I held during July, which was called Improving Trust Between Humans and Software Robots in Robotic Process Automation. All the researchers from this seminar were coming from 3 different areas, which were business process management, robotic process automation, and human-centered AI. First of all, let's give you a little bit of context of what is BPM. Business process management is a discipline that studies how to, let's say, organize business processes in order to achieve a business goal. A business process is a collection of different activities that could be automated. And it is exactly in this moment that robotic process automation comes into play, because it allows you to automate those tasks. And let's say, I come from the RPA field. The goal of RPA is to emulate these user actions with software robots. For example, an example of tasks that could be performed are the login into application, the connection to system API, to emulate the keyboard inputs, the mouse movements and clicks, and so on and so forth. So all those tasks that can be, let's say, repeated over time. Here it is an example of software robot. A software robot mimic the user actions that have been performed in the graphical user interface of a computer system. And here we have a GUI, a graphical user interface with combo box, text box, radio buttons, and the software robot is able to click on the different elements. Nowadays, we have two different types of automation: attended automation that require the human in the loop, while unattended automation does not require the human in the loop. And the software robots here works, let's say, without the human intervention. In this context, the goal of the seminar was to, let's say, give, let's say, a perspective on the challenges that should be realized to realize a new wave of trustworthy robotic process automation in order to support, let's say, an amalgamation of humans and software robots within a company. But why this seminar was, let's say, important? Because in RPA there was three different, let's say, not problem, but say motivation that are fueling the objective of this seminar. For example, the remanualization issue. The remanualization issue is a problem that once the software robots are implemented, eventually they are failed to be deployed, and there is, let's say, the humans roll back to the manual work, and this is, let's say, a trust issue in the software robot. There is no existing framework for conceptualizing trust as a measurable construct, but just for qualitative models. And also the integrative AI is fueling autonomous RPA, and this autonomy will increase also the perceived uncertainty of the tasks that have been conducted by the software robot. In this direction, the contributions of the seminar were threefold. First of all, we defined a conceptual framework for trust between humans and software robot. We specified trust as a measurable construct, and we inferred three relevant research challenges that are useful to be tackled for enabling a new, let's say, trust-aware software robot. Of course, these three research challenges are just the ones that we have identified. That could be also other ones that can exist. So, starting from the contribution, we derived three research questions that I'm going to discuss with you one after the other. The first one is, what are the fundamental entities and dimensions of trust that may impact RPA acceptance? We defined a relationship between three different entities: the user, trust, the software robot, toward a task. Specifically, we thought that for each entity, all these properties are the ones that can affect trust. For example, for the user, the inclination to use RPA based on his subjective criteria can affect trust. Also, the role of the user. For example, in a company, we can have both managers and employees, and depending on the role, it can affect the trust. Also, the software robot has different properties that can affect the trust. For example, the level of autonomy will affect trust, the mode of interaction that could be through a conversational user interface, a graphical user interface, or without any user interface, and the controllability, because the software, if I can control the software robot, maybe I'm more willing to trust it. For the task, we identify two different properties: the perceived uncertainty. For example, if I perceived that the outcome of the software robot is uncertainty, let's say I'm not willing to trust the software robot, and also the expected consequences, because if I have bad expected consequences, maybe my trust level is going to decrease over time. Research questions number 2. How do we conceptualize the notion of trust between human and software robot as a measurable construct? In this slide, let's say we thought that the extent to which a user can trust a software robot is his willingness to give up control. If I can give up control to my software robot, it means that I have a high level of trust. And this means that I can indicate the level of trust as the willingness to give up control. The higher is the willingness to give up control, the higher is the trust. Okay, and in our opinion, the properties that can affect this willingness to give up control was the perceived uncertainty of the task and the negative expected consequences or positive expected consequences. Research question number 3. Which challenges should be taken to develop RPA systems that effectively foster trust within hybrid workforces of software robots and human employees? So the goal is always to find a trade-off between software robots and humans. And we identified 3 different research challenges to tackle this research question. The first one is the need of calibration between trust and trustworthiness. It is important to emphasize that trust is different from trustworthiness, because trust is an extrinsic attribute that, let's say, a user can put on the software robot, while the trustworthiness is an intrinsic property of the software robot, based, for example, on his ability to achieve a certain task. If we look at the top, we have a categorical model in which I trust a trustworthy software robot. I trust a software robot that it's not trustworthy, and it is a problem. I do not trust a trustworthy software robot. Also, this is a problem, because if the software robot is able to achieve its task, why do I not have to trust it? And the other case is the correct one. So in which I do not trust a software robot that are not trustworthy. The goal of this challenge is to shift from a categorical model to a gradient trust calibration scale. And what does it mean, a gradient trust calibration scale? We would like to define, of course, these are a call for open for other works, in which it is possible to quantify the disalignment. Research challenge number 2, need of understanding the right trade-off between autonomy and trust. In this table, we can see 4 different types of RPA, in which they are divided based on the nature, for example, of their input data. The data could be structured or unstructured, or their decision-making that could be rule-based or based by AI and machine learning technology, also based on the adaptability of the software robot that could be pro-reprogramming or pro-learning. Saying this, and assuming that, let's say, there is an inverse relationship between trust and perceived uncertainty, the more is the autonomy, higher are the trust requirements we need to respect by the software robot. Research challenge number 3, this is, let's say, this is a parameter that should be followed in order to ensure that the trust is going to increment by time. For example, when the first time RPA could be introduced in the company, employees can feel that their job will be replaced by the software robot. By increasing the, let's say, the ability block by block, we arrive to increasing the personal development of the user, for example, by following courses that allows him to train himself in using RPA, for example, as a colleague, it will enhance the trust level that the user will have with respect to the technology. I would like to say that this is not empirical research. During the seminar, we were at the blackboard, so all the outcome of that seminar are, let's say, under submission in this journal, which is called Business and Information System Engineering as a research note. And say these are not the final results. We would not like to state that if we are going toward these research challenges, then we have trustworthy RPA. That was not the message. It's just the outcome of this seminar. And this concludes my talk. Thank you for the attention.
Thanks, Simone. Are there any questions from the audience?
The reason is that in RPA, from the very beginning, software robots are just piece of code. Okay, so there was no AI at the moment. Okay, so this terminology is from 2016, 2017, and we continue to call them software robots. So for, let's say, they could be software agents, of course. Indeed, in this seminar, there was also people from human-centered AI also for this reason, for, let's say, for merge the different terminology and thinking between the different communities. But they could be software agents, yeah. No. Exactly. Oh, well. Yeah, of course. We are, for example, there are no humanoid robots, of course. It is just software. Sorry, Luca. Yeah. Is different from the AI field. For example, here what I see in RPA, the trust is more also on the adoption of the technology. Of course, also to give the, let's say, the software robot the ability to deliver the task, and I need to, let's say, to trust the outcome of the task. But the problem is at the origin. People fear to use RPA. So here the task is more, let's say, on the direction of the technology adoption. That I think it is different from the traditional software agents. Okay. Do you have questions? I don't know. Okay.
Yeah, I know that today is a little bit abused, the use of LLMs.
Yeah.
But something that comes in my mind when speaking about trust is, do you think could benefit trust the use of an LLM, like an explanation of the software robots? I'm doing this operation because of that, or because
I think that there is a lot of research, let's say, in the USA, for example, there is a ChatGPT operator that allows you to, it is not yet available in Italy, because it's just in the USA for pro users. It is able to let you to give the prompt, and it executes the task for you. But of course, now, from what I've seen, because I did not try, you need to be very, let's say, diligent to specify the task in order to let him to be performed over the user interface. So I think that, yes, also that there is a trust issue. I trust if the result is correct, otherwise I do not trust it. So I think that employing a large language model, of course, it is an off topic now, but it will, let's say, based on this pyramid, I think we are going into the autonomous RPA direction. And so more trust requirements are needed for trust in LLM solution, in my opinion.
So do you think will destroy trust?
Exactly, exactly. We destroy trust. Large language model. There is Roberto here? No.
Okay.
You're welcome.
Okay, the next talk is by me. So I present myself. I'm an RTDA at TIAG. I work mainly on work package 5.1 and TP4. And today I will speak about how to integrate logical knowledge, in particular in linear temporal specification in deep learning applications. Okay, why do we need neurosymbolic integration? Basically because despite the great success of deep learning models, they still suffer some important issues, like, for example, the lack of explainability, lack of control from the user. They could be very data inefficiency sometimes. They can poorly generalize to out of distribution data. And they are all issues that I think they could be mitigated by using prior structured background knowledge in a logic formalism. In particular, in my research, I focus on sequential domains that can be captured using linear temporal logic, specifically LTL over finite traces. And we will see two applications of this integration, one in non-Markovian reinforcement learning and the other in suffix prediction, so in data generation. So both these two applications are based on the same methods. We developed this neurosymbolic framework that is basically a neural network and a DFA at the same time, because it's based on probabilistic relaxation of automata. So if we have a knowledge in LTLF form, we can translate it into a DFA, like the one that you see here, and we can translate this DFA into this neural model that is, of course, continuous, differentiable, and it can be applied on a sequence of symbols that are not exactly grounded, but they are grounded probabilistically. In fact, you see the model takes as input a sequence of probability vectors of dimension equal to the dimension of the alphabet symbols, and outputs the probability at each step that the sequence is compliant with the formula or not. And this probability can be optimized in a loss function that can be embedded in other neural architectures. So the first application that we see is non-Markovian reinforcement learning. So we have an agent that is required to execute a task that is extended in time. And in particular, we focus on a task that can be captured by LTLF. Here we have an easy example. We have this agent inside a grid world that is a Minecraft-like game. It has to open the door, but in order to open the door, it has to collect before a gem, but it cannot collect a gem if it's not possessed a Pikachu. So basically, it has to realize the sequence Pikachu, gem, and door, while always avoiding the lava cell. This specification can be expressed in LTLF and converted in this automaton. And this specification in a non-symbolic environment is not enough in order to solve the task, because another important crucial information that we need to estimate is the so-called symbol grounding function. So if the observation we see in environments are like these images, are not symbolic, we need to create a mapping from images to symbols in order to exploit our knowledge. And we create this two layers architecture in which the first layer is the perception layer and that we train over time, and the second layer is deep DFA, our model that is initialized with the knowledge that we have. In this way, we can train the symbol grounder in a semi-supervised fashion by trying to predict the next reward at each step. By estimating the symbol grounding, we can use our estimation to estimate also the DFA state. And this DFA state is concatenated with the observation in the environment, so to mitigate non-Markovianity. We have some results in many domains and different LTLF tasks. We have observed that our approach, the blue line, greatly outperforms the deep reinforcement learning approach based on a recurrent neural network. And it tends to have more or less the same performance of this green line, which is the performance of reward machines with prior symbol grounding knowledge. So if we knew from the beginning both the LTLF and the grounding function, we would have this performance. It is very, very similar to the one that we obtain without any knowledge of the symbol grounding function. The second application is we employ our method in sequence generation. Sequence generation is massively used, for example, in NLP. Basically, we want to predict the next symbol, even a sequence of past symbols. And we do it by estimating this probability, the probability of the next event conditioned on the sequence history. This probability is generally estimated using autoregressive deep models like recurrent neural networks or transformers. And at this time, these models are queried step by step, multiple times, so to compose the final sequence, the final suffix. Like in this image, we start from the empty prefix, we predict the next symbol, the desired, we concatenate with the prefix, and we continue to predict and concatenate, while at the end we have the complete sequence. Even in this task, we can we developed a logic loss that basically takes the symbols predicted by the RNN. So this is the prefix that is given to the recurrent model that predict this suffix. The concatenation of prefix and suffix is given to the deep DFA model, which extracts the probability of being compliant with some specific knowledge. In this way, we can train the RNN to, by combining the logic loss and the supervised loss, we can train the RNN to, at the same time, construct sequences that are similar to those seen in the dataset, and at the same time compliant with the knowledge that we have, so we can impose knowledge from outside. Here we have some results. We have seen that if we train the RNN with knowledge plus data, that is our model in green, we have more or less the same next activity accuracy, but we have on suffixes a greater knowledge satisfaction, so the constraints are more satisfied, and a smaller DL distance from the ground to suffixes. So the error on the prediction is smaller. So in conclusion, we have seen that neurosymbolic approaches allow the integration of symbolic temporal knowledge in real-world domain. That could be non-symbolic domains or generative domains. And this integration is capable to improve the neural network model in many ways. In particular, improves performances, increase the compliance with logical knowledge or logical constraints, improve the sample efficiency, and also the generalization. And that's it from my side. Thanks for your attention. Are there any questions? Yeah, I was very fast because of time limits. Yeah, here we have the recurrent model that takes the first event and predict the next one. Okay, it takes the first two events and predict the third one. Here, an important feature that I didn't mention is that we need to sample the next event with a procedure that is differentiable. For this reason, we use the Gamble softmax that produce a nest symbol that is nearly symbolic, nearly one-hot, but at the same time is differentiable. And this new event, a new symbol, is concatenated with the prefix, and we continue until we reach or a time limit or we predict an end of trace symbol. And this sequence, which is the result of the prediction, is also processed by the DFA. It's continuous relaxation of the DFA, which at the end it predicts whether the sequence is compliant or not, and we want to maximize compliance. So at the end, this loss is backpropagated through the DFA to the weights of the RNN also. Yes, was a paper from published in PMI at the workshop at the CAI 24. We are still working on it because for now we have only these results are from synthetic data sets, and we are trying to apply to real data set. The problem with real data set is that it's hard to extract the logical knowledge. If the logical knowledge is not satisfied completely, it may be tricky. Okay, if there are no other questions, I think we can stop here and go to the coffee break. Thank you. Bye. See you later. Okay. Okay, we can start again our session. Please take place. Okay, I will let some minutes still and then we can recover. In the second part of the session, we will have free talks from academic cascade called projects. So I'd like to invite the first speaker, Emanuele Menegatti, on the stage, who will present the Intellecto project, an intelligent exoskeleton with adaptive gait planning and 3D vision obstacle avoidance. La provo, se non più da seguire. Ah no, scusami, la tua quella l'ho caricata.
Perché sono 250 mega.
Okay, the stage is yours. Thanks.
Thank you very much, Elena. Okay, so good morning. I'm presenting the project that we have in the Cascade call that is called Intellecto. And it's a wearable robot that we want to make intelligent, and so not autonomous, but able to work with a shared autonomy concept, and so to be a collaborative robot for humans that need help to walk again. And the principal investigator is not me, but is my younger colleague, Stefano Tortora. And this is the project is the continuation of his research work for his PhD and his postdoc. So the state of the art of this technology of robots that are wearable for lower limbs is robots working in open loop that can restore the motor functionalities of disabled people. But they are not used in everyday life. So even current product and the most advancing one are not usable by the end user on an everyday basis. Why? Because they need the assistance of a therapist in most of the systems. So they are used in a closed setting, and so in clinics. And they have pre-programmed walking patterns, so you cannot decide the length of your step at every moment, but it's calibrated on the user kinematics, let's say, and then they do always the same step. Especially if you have an structured environment. Here we see a clinical setting or an outdoor setting, but actually the floor is flat, there are no obstacles, and so it's a structured environment. We wanted to face these two challenges. And the first thing, as we know in robotics, is to be able to perceive the environment in order to have an intelligent behavior. So we put vision on board of the exoskeleton, and we want to be able to reconstruct the environment in which the exoskeleton is moving, and then to be able to generate trajectories for the legs of the user in real time. But all the systems that we know in robotics are not good. So even the work we saw before that is planning the motion of the humanoid robots for walking around, we cannot use these solutions because we need also a physiological pattern of motion. So because we have a human in the loop, or even
deeper human in the machine. And so when the robot moves, it must take into consideration how the legs of the human are moving. And so we want to learn from human movements, not from robot movements. So this is the two objectives. These are the two objectives that we have in this project. So the first one is about robot vision. So we put a camera on the chest of a exoskeleton, and we want to be able not to have only a geometric representation of the scene, but also a semantic understanding of the scene. So we can classify the terrain in walkable terrain, obstacles that we should avoid by overcoming them, or obstacles we should avoid by negotiating them, going around them. The second objective instead is to be able to learn the human behavior. So by looking at people walking around and avoiding obstacles like in the previous clip, we want to be able to drive the joints of the exoskeleton in order to do these collision-free trajectories. So we already have some results we presented last October in IROS, in which we set up the whole architecture and we worked on the perception part. And so we tested these collision-free trajectories that we are able to generate in real time. But this is only the initial step, as I said, because once we have the perception of environment from the point cloud, as you see on the right, we needed to first understand which region of the environment are walkable, and then we needed to plan the path and the footsteps. So in yellow, you see the position for the next position for the foot that is generated on the floor. But this enables us to overcome one obstacle, but actually in most situations you have several obstacles. So you need to plan at once multiple steps, okay? So finding a trajectory generator able to plan multiple steps and to have this motion that account for human physiology is not easy, and this will be the work of the next months. The first thing we tried in the last months, and so during the course of this project, resulted in a preliminary walk that was accepted at SIMPAR conference that will be in the next months in Palermo. And is about using deep reinforcement learning to learn the trajectory, to learn how to generate the trajectories. So we have a DeepQ network that is already learned the motion pattern of human gait, and so we have a reward function that have two terms, and by inputting the state of the environment and so the depth images to this network, the network is able to generate trajectory, or better, we generate waypoints in the sagittal plane that the robot interpolating created the trajectory. We have these two terms for the reward function. That is, one is taking care of a trajectory in the sense that we try to limit the number of waypoints, and we have a control on the smoothness of the interpolation of this waypoint. And also, we want to keep the maximum distance from the obstacle to be safer. But at the same time, we have another reward function that is trying to take into consideration the kinematic constraint. And so we have kinematic consistency of the step, and then try to minimize the raise of the leg, because we don't want people to raise the knee too much, and also the joint angles, because when the human is walking, the natural walk try to minimize the effort on the single joints. So the combination of the two terms is looking for the trade-off of avoiding the obstacle with a safe distance, but to have a trajectory that is physiological. So this is the early result that we have in simulation, in which we see that the robot is avoiding the obstacle, but for instance, we are not controlling the center of mass of the exoskeleton, okay? So it's working on several trajectories, but now we want to do better. So what we have in mind is to, as I said at the beginning, to learn these trajectories from human data. So with GMM, we extract, let's say, a general trajectory of out of several demonstrations from human walking on the floor with a motion capture system. And then we have a GMR to generate this new trajectory. We get in input to this system, we give the endpoint and the start point for the trajectory, that is the actual position of the feet and the final position of the feet that is decided by the vision module I was presented before. The advantage of this system is that we control also the trajectory of the center of mass. That is something very important for a wearable robot that has to balance not only its weight, but also the weight of the body of the user. So in the end, what we have these boundaries that you see on the left, that are the physiological boundaries of people walking. And we have these red dots that are the waypoint generated by our algorithm that fit within the boundaries. The result of a trajectory is the obstacle you see below that are avoided by our system. Here we see different simulation for avoiding different obstacles. Actually, the first one is walking on a slope uphill and downhill. Here the starting point and end point are easy to calculate. More difficult is when we have either an obstacle to overcome or a step up or down to do. Because obviously, if you have the obstacle, the starting point and the end point are fixed and they are an additional constraint. These are the results that we have on the real machine. And so we have this exoskeleton that is an open source exoskeleton. It's not a full assistive exoskeleton because the motors are too weak. So we cannot use it with a paralyzed patient, but we demonstrated that we can overcome the different obstacles depending on the structure of the environment. So we hope that this AI that we are putting into the wearable robot can be used in everyday life by patients that need exoskeleton. And the key point I want to stress is the fact that in our approach, the exoskeleton is not just a tool, is not just a wearable robot, but is a semi-autonomous robot, so an intelligent robot that is collaborating with the human that is inside the machine. Even because we want also to add to this the perception of the human, so sensors to detect the activation of the muscle and the activation of the brain. What we would like to activate in the next months, next few months, hopefully, is the collaboration with you, the researcher of the Spoke5. And so, for sure, we are interested in collaboration with Giorgio for about mapping and SLAM algorithms that are suitable for lower limb exoskeletons, because obviously if the camera is mounted on the exoskeleton, we have issues with a moving sensor with jerky movements and so on. And also the field of view that we need is quite unusual for robotics or autonomous driving, all applications which most of the SLAM algorithms were developed. But at the same time, we are also interested in explainable AI solution in order to improve the human-robot interaction. And so in another project, we are working a lot on trust of the user toward this kind of devices, because one issue is when you are inside the exoskeleton, you do not feel confident, okay? You are not collaborating, you are fighting with the exoskeleton. So this is a real problem for the uptake of these solutions. We would like also to collaborate on augmented reality in order to give the user a feedback on what the exoskeleton is doing, exactly to preempt the exoskeleton will, let me use this term, in order for the user to know what is going on, okay? Because we believe this will help this collaboration. And then also we need more work on the biomechanical validation of the motion that we can achieve with these technologies. So if people are willing to collaborate on these topics, we will be very eager to collaborate with. Thank you very much for the attention. Yeah. Mm-hmm. Oh. Okay, let's say at the moment we are not learning from the single subject. Okay, so all these curves are learned from other people, not the subject that is in the exoskeleton. And so we have an average walking pattern, trajectory, whatever. Okay, and so when we generate this trajectory, this is based on general physiology of the people and not on the specific of the user. Even because we are thinking of users that do not have now a physiological walking, because they are fully paralyzed, so we cannot learn from them because they cannot walk. But what you're saying is very important, because instead, there is a mechanical adaptation to the single user, in the sense that most exoskeletons are adjustable on the specific kinematic chain, let's say, the specific physiology of the user. So our system must be able also to adapt to this change of kinematics. So the mechanical kinematic of the exoskeleton will be different from every user. So this for sure, yeah. Thank you very much. I'm sorry. I heard otherwise I will close. Okay. We'll pause. Mm-hmm. Mm. Yeah. No, I would say that no, we didn't have much of this gap, in the sense that what we generated from just the simulation was used to prove that the system was working, and then we moved directly to the human data, let's say. Okay, so no, yeah, no, in this sense, no, yeah. Thank you very much.
So I invite the next speaker to the stage, who is Alessandro Farinelli from University of Verona. Will present the Behave project, Learning Safe Behaviors for Human-Robot Cooperation, first results. No, tanto parte.
Okay, so thank you very much. I'm Alessandro Farinelli. I work in University of Verona, and what I will be presenting today is the Behave project, which is one of the projects that has been financed through the Cascade funding of FAIR. Essentially, the Behave project focuses on trying to go beyond empirical evaluation for what concerns safety. In particular, I don't have to convince you, I guess. We know that there have been a lot of advances in planning and learning in specific environments, such as, for example, games. But when you go to realistic environment, robotics in particular, things become much harder. And so I think one thing that we would like to do in this project is to go beyond empirical evaluation. And when I say this, what I mean is that if you try to do deep reinforcement learning algorithms on simulations, for example, in various domains, you typically have curves that looks like this, that they becomes much, much better over the different episodes. And if you stop, I don't know, in this case, for 40,000 episodes, this system is working very well. This is the percentage of success for robotic navigation. So this is a system that nearly 100% of the time reaches the target. But then when you deploy this system in the real world, things like this happens. And what you see here is a robot that cannot find the way to the yellow cell, which is the target position. And what you can see now is that if you insert a new obstacle, so things becomes harder, the robot can actually find a way. So what this shows is that the robot is able to find the path to the goal, but the specific configuration that we've seen before has never been seen during training, and this causes a problem which sometimes is called adversarial inputs in machine learning. This is the typical keywords that we use. So finding this configuration is very difficult, and what we would like to do is to change the way we develop these algorithms and we evaluate these algorithms to try to combat this problem. In particular, in Behave, there are 3 lines of research. I will quickly go through 2 of them and focus a little bit more on the third one, which is the one where we have some initial results during the project. So the first one is formal verification of deep neural networks. So there are some tools that have been developed in the last, I would say, 5 to 10 years that allows to formally verify a neural network, which means after you do the training, you can then formally show that some properties are respected by the network. This is typically done through interval analysis, interval propagation, interval algebra. And we have been working quite a lot on this, both trying to develop new approaches for DNN verification, which of course are approximate, because you can easily imagine that is an NP problem, so impossible for big networks. And we are also trying to apply this to robotics for specific type of tasks, which essentially are based on mapless navigation. So this is one line of work that is mainly handled by Luca Marzale, which is a third-year PhD student and is working on these topics. Second line of work is neurosymbolic planning and learning. And in this area, what we are trying to do is essentially to say in few words, is to encode the knowledge that an agent can learn from the word into a symbolic representation to then use it in generalization. So for example, here in a simple, very simple and small rock sample domain, rock sample is a well-known benchmark for planning under uncertainty. What we do is we learn from traces, and in this case, we learn with a model-free approach. We learn rules, which are of type, let's say, interpretable, in the sense that it says, if the rock is close, then try to sample it, things like that, using human-defined predicates to guide the learning. And then we use this rule in the reinforcement learning approach in bigger domains, more complex domain. And what we have seen is that the symbolic guided exploration is much, much faster and much more sample efficient and can solve problems that otherwise are impossible to solve with the standard reinforcement learning approach. This is also work where we have some result before the project, and we would like to continue the collaboration on this. And the two people that are working mostly on this is Daniele Meli and Celeste Veronese. Daniele Meli is a researcher in Verona. Celeste Veronese is a PhD student. Third line of work is the one that I will go a little bit more into the detail, and is essentially based on model-based reinforcement learning, when we want to bridge planning and learning together. And the idea here is that there are a lot of powerful approach for model-based reinforcement learning, but typically the model is not given in the real world. So what you want to do is to use a model while for planning, execute, and try to change the model by using the experience. This is more or less the idea. In this area, what we've been working mostly is this concept of safe policy improvement, where you have a baseline policy that is working in the environment, and you want to essentially make this policy better in the sense of the return that you get at the end, with some probabilistic guarantees. So you want to modify the policy only if you are fairly certain that you're modifying it to improve the return. And on this, we had two papers recently that is for scalable, is essentially safe policy improvement, so to try to scale this to realistic systems, and also for multi-agent. And the two people that are working on this is Alberto Castellini, which is an associate professor in Verona, and Federico Bianchi, which is now a postdoc, just finished the PhD. Along this line of research, the first result that we had during the project, during the Behave project, and I would like to show a little bit more in detail, is trying to use online planning based on Monte Carlo research to have safe and efficient motion planning in open environments, where essentially the problem is this: you have a robot that needs to reach a given goal, you have moving obstacles on which you don't know the trajectory of these obstacles, and you want the robot to safely reach the goal position. Essentially what we are trying to do, I will try to explain this better, but more or less is well represented by this animation, where you see that the robot is planning the next trajectories while moving. And as you can see, this planning is directed towards the goal, because one of the big problems here is that you cannot do too many simulations, otherwise the time in which you're planning will be too long and you are completely out of date with respect to the situation that you're facing. So this is one of the key elements that we're trying to push here. In a little bit more detail, what we are doing is essentially combining two well-known techniques. One is called Monte Carlo research, which probably most of you have heard, and is essentially an advanced search-based method that creates a tree, but it does not create a balanced tree. It's an unbalanced based on the exploration part, which is trying to go directly towards the goal, essentially. It's used very much both in reinforcement learning and for planning under uncertainty. We are using it as an online planner. So it selects the next move, then plans, selects the next moves, and so on. The problem with Monte Carlo research is that the selection phase, also simulation, but essentially selection, can be very time consuming, because most of the time at the first node, you have too many actions to select. And so it either gives you no real information or you plan for too long. So what we are trying to do is to exploit some knowledge on the domain, and in this case is the fact that we want to avoid moving obstacles, by trying to avoid some actions. And the actions that we avoid are the ones that will bring to a collision, according to the velocity obstacle paradigm. Velocity obstacles is a well-known paradigm for computing the feasible velocities of a moving robot when other robots are also moving. So we essentially compute the feasible actions by using velocity obstacle, insert this into the selection phase, and then run Monte Carlo research. This is in a nutshell what we are doing. The interesting thing about this approach is that the assumption that we make on the obstacles are minimum, in the sense that what we need to know is the position that, as I will show you, is estimated from LiDAR, and also the maximum velocity, the maximum speed, so the maximum amount of speed of the obstacle, not the vector, the maximum speed of the obstacle. And this is what we use in the planning part. This has been accepted at the next AMAS, and we will go to present this in the US. So what we did is essentially do an empirical evaluation in synthetic environment. This is part of the AMA's work. And as you can see, the type of environments are very crowded. So we have a lot of obstacles that move in a random way around the position. And the robot, which is the blue circle here, should reach the red target. We did different scenarios, randomly varying the initial position of the obstacle, and we compared with some of the most well-known planners, both, let's say, look-ahead planners, such as, for example, an MPC, but also reactive planners, such as dynamic window approach, which is one of the most famous velocity avoidance algorithm. We also used, obviously, our approach, which is the Monte Carlo tree search VO, Monte Carlo tree search without the velocity obstacle, and then a planner based only on velocity obstacle. And essentially, what you can see here is that this is the collision rate. I reported this because it's one of the most interesting part. And as you can see, the Monte Carlo tree search with the velocity obstacle inside the tree expansion reaches always zero collision rate in all the experiments that we did. In fact, what we can also do, to go a little bit the empirical evaluation, is that we can guarantee collision avoidance only on the next step, however. So under some reasonable assumption, and in particular, one of these assumptions is the fact that the planning step should be less essentially of the movement of the robot, then you can guarantee to avoid collision one step ahead. This is not very strong because, of course, over the time you can run into an issue because you didn't plan in advance, but since you don't know anything about the obstacles, this is all you can do essentially. Then the new results, which is a work that we are doing at the moment, are for a realistic simulation. So now we are working on a more robotic-oriented domain. And essentially, this is a Unity simulation with a Ross bridge. So this is now something that can be placed on a real robot. And this is what we would like to do next. This is the type of environment, and this is the robot that needs to reach the yellow target. In this case, you can see that there are some obstacles fixed with different geometry, and some moving obstacles which are moving according to a sinusoidal movement that the robot, however, does not know. And what we are doing here is that the robot is planning, this Monte Carlo research planning, then executing, observing, planning, and so on. The first results that we got are very interesting. So essentially, this is the planner that uses only velocity obstacle. This is the one with Monte Carlo research and velocity obstacle, and this is the one only Monte Carlo research. Obviously, the success rate for Monte Carlo research is very low because it cannot reach a reasonable expansion or a reasonable exploration of the tree in the small time step that we allow for planning. While in our case, we can reach 90% of the success rate and crucially 0% of collision. In this case, also the velocity obstacle planner does not collide voluntarily, if you want, so it never does a move that goes against an obstacle, but since it can be trapped in situation where all the obstacles are going against the robot, it cannot avoid collision in any case. Okay, this is all for what concerns the main results of the work. Just as a last slide, what we would like to do during the course of the project is to apply not only these techniques, but in general, this idea of self-assessing the quality of an artificial intelligence system in realistic robotic simulation. And this is one part, in particular in aquatic navigation. So we have this water drone that we developed over the year that we would like to use as a research platform to test some of these approaches. Obviously, we are very happy to collaborate on the different topics that I mentioned. On some of these topics, we are already starting some collaboration, particularly with Luca on the neurosymbolic part, but I guess there will be many more occasions to go ahead and collaborate on these topics. Thank you very much. Okay, so the first for the comment, which okay makes perfect sense. In fact, this is what we clarified in the paper, that we are not working in an adversarial domain. So technically, you can still guarantee collision avoidance if you are not already inside, because we enlarge the obstacle essentially with their maximum velocity. So if you start from a situation where you are not inside one of the region where the obstacle will hit you, you will never, let's say, voluntarily take a step towards one of the obstacles. You will always remain in a safe area. This is guaranteed, but you're not guaranteed to reach the goal, and you're not obviously they can surround you, and so you have no choice then. And this needs a different model, because then it becomes strategic. So it may be very interesting to go in that path, but it makes sense. So for the other question, this is a good point, because of course, when you have less obstacles, so what you're doing in the Monte Carlo research is discretizing the search space. So there may be smoother trajectory that will bring you to the goal without avoiding to essentially change too many times the orientation of the velocity. This is more or less what's happening in this. See now the video is not running very well, but you can see more or less the domain. So this is, I guess, more similar to what you were saying. So this is not very crowded, and you have a couple of obstacles. This is the type of domain that we're testing now. And first results in this type of domain is this one. So it's still working very well with respect to, of course, the competitors that we consider. Yeah, it's a very good point because it's one of the main part of the work. So in this case, we are still using. So there is no general way of doing this. It depends on which planner you use in the generalization domain. We started this work by using again Monte Carlo research. And so what we were doing is essentially bias the search of Monte Carlo research towards action which are inferred by the rule. Exactly, yes. And exploiting the rules using the Monte Carlo research for planning, yes. We tried also something which is ongoing work on deep reinforcement learning. So in this case, we are doing reinforcement learning, and we are trying to bias, once again, the exploration by using the rules. Similar to the board shaping, if you want, in general, exploiting the rules to guide the exploration. In that case, we are doing pure reinforcement learning, so to say. But in this work, we're using just planning in the generalization part. Thank you.
Okay, we're ready for the last speaker of the session. Alfonso Emilio Gerevini from the University of Brescia will present the Resilient Plants project. No, I have downloaded. Sì, già l'ho scaricato. PDF di Drive. Questa l'avevamo aperta prima, aspetta. One moment, please. Okay, I don't find it the problem now. Il problema dove sta?
Hai scaricato il file?
Sì, l'ho scaricato.
Ok, downloads.
Ah, ok.
Downloads. Ok.
Questo qua, sì.
Ok, tasto destro. No. Ok, ok.
Da qua.
Control P.
Così. Ok, you're done. Dove sta? Non vedo.
La presentazione. Sì, certo. La Control P.
No. Puoi fare su e giù così.
Good morning or good afternoon. I'm Afonso Gerevini. I'm going to present one of the planning projects that we are carrying out in my research group at the University of Brescia, which is work done with the support of the Cascade funding from FAIR. So this project is about resilient planning, and let's start with some very simple motivations. By the way, these are not the very last slides that I prepared, but I will keep going on this. I don't know why. So in classical AI planning, we have very good techniques to generate plans from models of actions and states that have guarantees in terms of correctness and are valid plans. But they are abstract actions. They use abstract actions. So when you put these plans in execution, they might fail because actions fails in a number of ways, possible ways, and you cannot very often anticipate all the possible failures that you will have at execution time. So, what can we do? Of course, we can try to handle these problems at execution time, but we could also try to prevent in some way these failures, or take them into account at planning time. And this is one of the main approach that we are pursuing in this project. So we would like to generate solutions that are resilient to a bounded number of possible failures, in the sense that our plans will not be completely wrong. We assume that there could be some actions, a limited number of actions that can fail, and we want plans that are robust with respect to these failures. What does it mean robust? That they have repairness guarantees, so that if the one or more actions will fail, we know that we will be able to generate alternative plans from these failures. So we introduced this notion of resilient planning, starting from classical planning, so from the simplest models of planning, and then we can continue and using more expressive models of actions. Okay, resilient planning problem is just a couple of two elements. So we have the formal definition of a planning problem using the classical setting, so a set of fluents, a set of possible actions, an initial state, and a goal. And then we have an integer that denotes the maximum number of failures that we want to we want the plan robust for. And the resilient plan, solving this resilient planning problem, is a solution plan for our formal planning problem that guarantees that in case we have up to K failures in the execution, consecutive failures, we will be able to recover from the states where the action fails by generating alternative plans. So we started with some assumptions that in the research, while the research progresses, we might relax. And so we have that when an action fails, the current state remains the same. So for example, if you try to switch on the light by pressing a button, but the light doesn't appear, so nothing changes. We also assume that we also force that if an action fails in that planning episode, the action should not be used again. So it's not repaired during that planning episode. It could be repaired later, but it's forbidden, the action if it fails. So a K-resilient plan is a plan where all the traversed states that are generated by the plan are resilient. And in particular, they are K-resilient. So we have the notion of bounded resilience. What is a K-resilient state? It's a state S from which we can reach the goals even if K failures occur in that state or in future states from that state to the goal state. Formally, we have that S is K-resilient for any K if it is a goal state, because there is nothing to do there. S is zero resilient if a plan from S to the goal exists. And then the more complicated case is the third case, S is K-resilient if there exists an action A such that its execution in S results in another K-resilient state, so we propagate to the next state this property. And in case the action that we execute in S fails, we guarantee that S remains K-1 resilient. So we have K-1 options, possibilities of failures, without using the action, the planned action that is supposed to fail at execution time. So using this, now I very briefly describe this concept with this in this scenario, and then I will present the techniques that we have developed and that we are developing for solving resilient planning. So suppose we have this logistic domain in which we have to go from A to G, and we have different options for moving from one location to another location by car, by train, by plane. And so we have different ages according to different movements. Okay. So we can label each of these transition system state in this transition system with a degree of resilience. So with the numbers are the maximum number of failures that can happen in that state and from that state in the trajectory to the goal. So F is clearly zero resilient because there is only one option. D is too resilient because you can fail twice from D to the goal and still be able to reach the goal because we have three alternatives from D, and so on. Okay, so in principle we could label each state in our state transition system with a degree of resilience. Obviously, doing this is very expensive. We don't want to do it offline, say, but we want to do it online during the planning algorithm execution. So we have developed the first algorithm called REST plan, which is actually implemented in a planner, and it's a very simple, exploits a very simple idea. Although the algorithm is not so simple, so the pseudocode is not here because it's a bit complicated. We basically find a plan for the planning problem, and then we verify that every state that is generated by this plan is K-resilient. Of course, it could be that some of the states are not K-resilient, so we have to modify the plan trying to make it K-resilient. So it's a kind of a search in the space of all the possible plans until we find a plan where all the states are K-resilient. The verification is done backward, starting from, this is the specific algorithm that we have defined for solving this problem, generates a plan that starts, and then we start from the last state of the plan, and which is for sure, since it's a goal state, it's resilient. Going backward toward the initial states, we verify state by state, it's resilient. If we find a state that is not K-resilient, then we replan from the previous state to the goal, and we repeat the check starting from the end of the plan. In doing this, it's very important to exploit knowledge discovered during this search, in particular states that have been already discovered to be not resilient, and states that have been discovered to be resilient. In this way, you can prune the search. Okay, so I go a bit faster. This is an example of the algorithm in our scenario, but I don't want to spend too much time. We go to the end of the talk, and then maybe if there are questions, I use the example. So we have developed this first algorithm, and in addition to this, we have studied the problem in terms of its compilability into other planning frameworks, in particular in the fully observable non-deterministic planning. So we have a specialized algorithm that's called RESPLAN, and a compilation into fund planning. We have tested the algorithm on a number of benchmark domains and problems, taken from the literatures and from competitions. And these are the first results that we got. We have the dark curve is the specialized algorithm, RESPLAN, and the other curves are the compiled, concerns the compiled problem using fund planners. We used 2 fund planners. And overall, we have that RESPLAN solves many more problems. So on the X, we have a CPU time. On the Y, we have the percentage of our test problems that are solved. So for K equal to 1, so we admit only 1 failure, the system works very well. While you increase K, the system works worse, of course, because it becomes more difficult. Here, solving a problem means either finding a plan that is resilient, K-resilient, or proving that there exists no plan that is K-resilient. Of course, the higher K is, the more likely is that the problem is unsolvable. So, but we also saw that RESPLAN has difficulties in proving unsolvability. So it's much better, it's very good in finding resilient plans up to K when there is a resilient plan, but it's not very good in proving unsolvability. So starting from this and this analysis, we have developed a new technique, and we are developing additional techniques in the future in the context of this project. So one first technique is to exploit landmarks in the algorithm, where a landmark is a fact or a formula, general formula, that must hold in any trajectory that leads to the goal from a state. Okay, so you can compute the landmarks from the initial state of your problem, but also from states that are reached by your plan. Okay, but you have alternative plans, alternative trajectories to go to reach the goal, and potentially from all of these different states you can compute landmarks. So we can exploit a very simple rule that says that if the number of achievers, so actions that reach a landmark is lower than or equal to k, then you cannot generate from that state a key resilient plan. By exploiting this inside the algorithm, we got significant improvements, especially for unsolvability. So you can see here that we have the blue curve is the new algorithm that exploits landmarks, and it performs much better than the original algorithm because it can capture many problems that are unsolvable. By the original algorithm, had to investigate and all the possible trajectories. So do a kind of an exhaustive search to prove unsolvability, while exploiting landmarks gives you a lot of pruning. Okay, so this is very recent work, not yet published, but we are submitting a paper on this. Other work that we are doing is something a bit more complicated for, again, exploiting non-resilient states and also states that are resilient, that uses some kind of regression of valid plan suffixes that we have already found. And when we do the replanning inside the algorithm, we try to reach a partial state, which is the regression of a plan suffix that we have already computed, that we know have as the resilient property that we want to achieve. So this is a bit technical, so I don't go into detail unless you ask questions. We are also doing, we have also already done actually, an analysis of all the benchmarks domains that we have. There are many benchmark domains from many competitions to understand their degree of resilience. And it's interesting, some competitions, for example, have benchmarks that admit only 0 resilience, other 2 resilience, but not much more. Then we are working on restricting the resilience only to critical actions, not to all the actions like now, and on resilience on objects. So, for example, we have some roads or resources or drivers, and they might not be available. They are available at planning time, but at execution time, they are not available. And we want to anticipate this with a robust plan with respect to these objects. Finally, almost finished. Other possible directions that we are considering is resilience not over the goals, but over temporary expected goals. So not standard final goals, but properties of the entire plan that you can express, for example, using linear terminal logic. And we have some work on this, on the planning with temporary extended goals that is almost state of the art. That's another project. Then we would like to model, we like to deal with deeper models of action failures, because at the moment we have actually no model. If an action fails, nothing happens, but you could specify that something actually happens when the action fails. And very recently we started working on the resiliency in the context of multi-agent pathfinding, which is also quite interesting. It has a different robustness properties that one want to guarantee. So conclusions, resilient planning is the problem of computing valid plans that have repairing guarantees for a bounded number of action failures. We have recently developed landmarks aware REST plan, which is an extension of the previous REST planning algorithm that we have developed in my group. And we are working on a number of techniques to improve this algorithm and making resilient planning more effective. Thank you. No, no, the approach here starts with say we don't model the reason why the action models because you cannot anticipate all the possible failures. So we just say, in case the action will fail for some reason, we don't know why, okay? We want to guarantee that from that state of the plan that I have generated, if the planned action fails for some reason, I think any action could fail, we don't know which one. From that state, you will be able to reach the goal. So if you have 3 actions, they can be any actions. If you have 3 states, for every one of them, you want to guarantee that if you don't use that action, you have an alternative path. But then again, from this alternative path, there could be another action there, and you don't know which one could fail, and then you want to fail, and then again and again, up to k times. Space complete. Yes. What you need is font planning actually. I don't know if no the standard. No. Okay. There is an approach that compiles it into planning through fault-tolerant planning. In terms of performance, well, you have a big overhead because inside of the you have to run the planners many times. Yeah, but that's why you have experimental results about you can only say how many times the planner is called. Because to verify the states, the resilience of a state, what you have to do is, I am in a state, I have planned this action. Suppose that the action fails, okay? Then I remove this action, and from this state, I replan then without that action. And you have to do this several times, up to k times, no? So you end up running the planner. I don't want to say an exponential number of times in the worst case. Didn't quantify it, but many times. So comparing range plan with a classical planner is not really meaningful. You can say how many times you run the classical planner inside the algorithm. No, no. Even the number of rounds. No, I haven't done it. So what we could do that because in order to find resilient plans, the first thing you have to do is to solve the problems of aggregation. You can save that time and then yeah. So what is the exactly? That's a good point because you could have a plan that is not resilient, and then it's up to you to handle it at execution time. But it could be that with that plan, you cannot replan. That's very important. So it's not the same thing. Because if you take a plan that goes in one direction and you cannot go back, that's straight, for example, and your car stops there, you cannot reach the one. While a resilient plan anticipated things, so it doesn't take that road. This is very important for example, refuel when you model resources. You have to be careful that in case something goes wrong, you have a place to refuel. Plan B. Yeah, also plan B. But not only plan B, plan B, C, D, A, up to K. Yeah. Exactly. Top of this, we are adding safety constraints. This is connected to the project that you mentioned in your presentation with Giuseppe, because we want to guarantee not only that we reach the plan, but that those constraints are maintained, will be maintained. Yeah, exactly. Yeah. You could yeah, exactly. Indirectly, yeah, exactly. In fact, there is a connection. Sorry, these are not the latest version of my slides. Unfortunately, there was some misunderstanding. In the latest slides, there was also this connection with the. No problem.
Okay. Thank you, Alfonso. Let's go to non ho terminato niente. Ho solo interrotto la condivisione, però
Guarda, così. Ho metto solamente in pausa la registrazione, lasciamo la sessione aperta.
Prova, ok. Okay, hello everybody, hello folks. Thank you for joining this third session of today's workshop. This session is devoted to data quality and generative AI. And the main goal is to show the results of work package 5.2, 5.4, TP2, and TP7. We have several contributions from several institutions, from La Sapienza, CNR, University of Bolzano, Tor Vergata, Intesa San Paolo, and Roma. Essentially, this is the schedule. As you can see here, some rows are highlighted in blue because they are in the form of talk plus Q&A session. The gray one are just the talk, the speaker related to the talk of the gray one rows. Is just they will just present themselves without Q&A. I want just highlight that in this session, we will be presented some really interesting works. To be more precisely, winner prizes papers in NLP. To be more precisely, of 2 top conferences in MLP and DCL, and another one of HKI. Okay, I think we can start. So I ask to Simone to come here and present semantic-driven AI, building smarter and more efficient large language models. Okay, maybe I have to download the slide just because I cannot present here in full screen, right? Okay. Then the combination of
Thank you for the introduction. I'm Simone, and today I will talk about semantics-driven AI, building smarter and more efficient large language models. I'm Simone Cogna, the speaker today, but this work also features work by many other people. And it's a collaboration between many universities and also some companies, including Bubblescape, Apple, and Adobe. So large language models today are everywhere. And at a very high level, we can say that large language models usually take as input raw text and output other text or structures. And since they are so general, they can be used for an increasing array of tasks nowadays, with increasing efficiency and increasing accuracy. So since LLMs are now used everywhere, one of our questions was, can we contribute back to how large language models are developed? And in particular, we wanted to take a look at whether we can improve large language models using semantics. This is one of the goals of Work Package 5.4, and Work Package 5.4 looks at many aspects of this problem here. Today, we are going to tackle these 3. And I want to, before talking about that, I would like to talk about natural language understanding. Natural language understanding is how we teach machines to understand the meaning of a text. And there are several traditional natural language understanding tasks that deal with semantics. Some of them are word sentence ambiguation, for example, semantic parsing, entity linking, semantic labeling, relation extraction, and so on. And most of these tackle semantics at different levels, at different layers, in different ways. Today, I would like, for example, to talk about semantic labeling. Semantic labeling can be defined as the task of automatically addressing this question: who did what to whom, where, when, and how. And it's somewhat a traditional task in natural language processing. To give you a better understanding of what we're trying to do here, let's take a look at this sentence. The quick brown fox jumps over the lazy dog. Semantic labeling first tries to identify the predicates in this sentence. The predicates are those words or multi-word expressions that identify an event or an action in the sentence. Then we have predicate sense disambiguation, which is to identify the most appropriate sense for each identified predicate, because predicates can be ambiguous. Then we have argument identification, which is to find the pieces of text that are semantically connected to each predicate. And finally, we want to understand what is the semantic role that connects each argument to their predicates. So this is a very brief introduction to semantic role labeling. And what I want to highlight here is that if we have this sentence here, for example, the cat chased the mouse that stole the cheese, we have first one of the main predicates is the verb chasing. And here we have an agent that is the cat and a patient that is the mouse that stole the cheese. But we can further identify another predicate, which is stealing. So, and this predicate here has another agent and another patient. So here we can see a very simplified overview of how we can extract the meaning of a sentence using semantic labeling. So over the past few years, we worked on creating an inventory of senses and roles that could be used for machines to extract these semantic parses. And what we introduced was verbatlas. This is a new inventory. However, verbatlas is still not sufficient to tackle semantic labeling at a larger scale. This is because there are sentences in which the predicates are not expressed as verbs. For example, here we have amazing discovery in Sapienza last night. There is no verb, but there is surely an action here, or robbery at the bank in plain sight. So this is the problem that we try to tackle in this paper here, Noun Atlas, filling the gap in nominal semantic labeling. So this paper won Outstanding Paper Award at ACL, one of the top tier conferences in natural language processing last year. And it's a collaboration between Sapienza, Bubblescape, University of Stuttgart, and Free University of Posen. So here we have an example, and what I want to highlight here is that these kind of examples in which the predicates are not expressed as verbs are quite frequent in a number of scenarios, like newspaper headlines, dialogues, short messages, and social media posts. So, and previous inventories to tackle this problem were still suffering from some issues. Here we have a number of them, the most popular ones. What I want to highlight here is that there were some resources for this problem. For example, NumBank, which was unfortunately discontinued a few years ago. What we worked on was verbatlas, which had the advantage of being able to scale, especially multilingual, but verbatlas lacked coverage of nominal predicates. So here, what the underlying contribution of Noun Atlas is to extend verbatlas to the nominal predicates. For example, here we have verbatlas, which has frames of verbal events. And we used WordNet, which is a semantic network, to connect each verb in a verbatlas frame to a noun, a predicate, a nominal predicate, in that we can add to a new frame of nominal predicates. So this is the high level of how we construct Noun Atlas. Just to give you a better understanding, we start from a seed of goal nominal events that are chosen manually. And then we extend this using the hierarchy of WordNet. And finally, we use some special relations in WordNet, which are called derivational related forms, to connect these new predicates to the verbal predicates in verbatlas. So just to give you an intuition of the results, The creation of noun atlas can enable semantic understanding of nominal predicate argument structures in a unified way with verbal predicates, which is very important to enable a true understanding of sentence level information for large language models. Now I want to switch briefly to another topic, which is neural machine translation. And what we noticed is that neural machine translation systems still struggle in some cases. For example, when we encounter challenging named entities. For example, here we have a sentence, qual è la trama del giovane Holden, and want to translate this sentence to English. And word-for-word translation or a literal translation would translate this sentence to what is the plot of the young Holden, which is wrong because the title is actually The Catcher in the Rye. So, and this is happens very often, especially with rare entities or emerging entities. What we try to tackle here is this problem, and this is the other paper towards cross-cultural machine translation with retrieval augmented generation from multilingual knowledge graph, which won another outstanding paper award at EMLP 2024, just a couple of months ago. And this is a collaboration with Apple and Adobe. So what we wanted to try to tackle is this problem, which is in the literature called transcreation, when word-for-word translations of named entities is not sufficient because there is something related to culture-related aspects, which could depend on social, geographical, historical, and political contexts. So, and this is a huge limitation for a number of cases, not just machine translation, but whenever we want to improve multilingual large language models, then this problem is also happens. And these systems are still used nowadays to create more and more synthetic data for, especially for multilingual settings. So in this paper, we wanted to contribute in 3 ways. And the main 2 ways are creating a new resource, which we call XC-Translate, and a method, which we call KGMT. And today I would like to just briefly talk about the method, KGMT, which is a method that integrates retrieval augmented generation from multilingual knowledge graphs into machine translation systems. So this is a standard machine translation architecture in which we have an encoder and decoder part. What we thought was, well, we can enhance this process by including information that is extracted from a knowledge graph, which is, for example, think about Wikidata. And we take this information and combine it in different ways into a machine translation systems at the encoder and decoder level. What we find is that a simple machine translation system is able to really outperform even state-of-the-art systems, machine translation systems like NLLB and GPT-4. This is just a conclusion. All the code and data is available online. And what I want to conclude by saying that these are 2 directions that show that we can have huge impact in the development of large language models, which are used, for example, in machine translation, by focusing on semantics, which makes everything also more interpretable in the end. That's all. Thank you for your attention.
Thank you, Simone. Thank you. Any questions? Okay, I have a question. If you go back a couple of slides, previous one, the previous one, okay, this one. So essentially, also, so the query is the embedding of the sentence, right?
The query is the embedding. Oh yeah, here is the embedding of the sentence, right?
And so also you are translating the KG into a vector space, right? Or you have some techniques to...
Yes, we are computing the representations for each entity of the knowledge graph. Wikidata, for example, has, depending on which subset of Wikidata you take, has about 5 million entities, so the vector database is about 5 million entities.
Okay, thank you.
Thank you.
Any questions? No? Okay, thank you, Simone, again. Thank you. Okay. The next one is Eduardo Barba. We will talk about Minerva.
Hi everyone. Can you hear me? Even if I look like this. Can you hear me? Yeah, okay. So I am Eduardo Barba, a researcher here at Sapienza. I will talk about Minerva, the Minerva project, and something about the evaluation of these kind of models. Of course, Minerva is a very, very large project, so I'm not the only one participating in this project. Today I will be the one describing it. Okay, so let's start with the background, the motivations, and which were the objectives of, and which will be the objectives of the Minerva family. So first of all, I don't have to convince you that large language models now are everywhere. Like there is an announcement every day about language models. And what I want to say before I start, it's very, very important that we do research on this, not just claims on social media and stuff like that, because this kind of technology has to be studied, and we don't have to rely on marketing and this kind of stuff. We have to evaluate what we utilize. So it's very important to do research on these kind of things like large language models and AI in general. So these kind of models are released every day. The good news is that there's a lot of companies that are starting to release technical reports on the way of they trained these kind of systems. Most of the times they are not complete. Okay, so you have something, some technical details on what they did. Most of the times you don't know many, many details. So most of the time you don't even know the amount of data on which they are trained and the data itself. Okay. Now, why we need Italian large language models? The first thing is that we still rely on research that is mostly driven by Anglo-centric cultures. Okay, so we still select architectural details, hyperparameters, all this kind of stuff is based and built upon research that is done only for English-based large language models. So most of the things that we build are not optimized for our language, okay? So this today is a problem. In the future, it will be a very big problem because we may end up having tools and instruments that are way less powerful if we use them in Italian, that is our language, okay? So, which were the objectives? Of course, starting with building a large language model, even to understand how far we could go, okay? Just utilizing Italian and English, doing open research, so addressing challenges for the Italian, thinking about the best architecture for an Italian large language model, and building know-how. So building know-how and people and communities in Italy that are capable of training large language models from scratch. Okay, these were the objectives. The Minerva project is a family of large language models, starting from a very small one. Today, when I started my PhD, it was very large actually, and that is 350 million. And the last model we released is a 7 billion model trained on 2.5 trillion tokens, okay? So, which were the challenges? Of course, the design of the architecture. We have many research on English-based large language models, some on multilingual-based large language models. We don't have much research on Italian-based large language models. So even the design was, a critical phase. Having data, collecting data. So as you may know, there are models that are trained on 30 trillion tokens in English. In Italian, we didn't even have 1 trillion token to train Minerva. Now things are getting better, especially for what regards synthetic data generation. Still, I mean, we have a huge disadvantage when we talk about Italian large language model with respect to English-based large language models. Compute. So we were lucky to use Cinega facilities. Today, Cinega is not anymore the best computer out there. It maybe will be again in a few years, but compute is still something that we have to, to invest on, and software. Of course, we gained a lot of expertise on the software that is needed to train these kind of language models. So, design. For example, if you use a model that is optimized for English, like Mistral, what you end up having is that the tokenizer fertility, so the amount of tokens that the model uses to encode a sequence is much, much higher in Italian with respect to English. What does it mean? That to produce the sequence in output in Italian or in English using an English-based large language model is 2.5 times slower than producing Italian sequences. So if I have to use Mistral in English, it will take 2.5 times less than using it in Italian. If we use Minerva, that's not true anymore. Okay, we built Minerva for the Italian language. So whether you use it in English or in Italian doesn't make any difference. So this is something that is usually, you usually don't take into consideration, but it's something that we have to. So this is a demonstration of why we have to design models for the Italian language. Open data, of course, I will be a bit more faster. You can see that there is lack of Italian data. So if you have to collect data in Italian, it's much more difficult than if you have to collect data in English. For Minerva 7B, to keep the same ratio of tokens per parameter, we had to use the same data in Italian multiple times. So doing more epochs on the same data. There are quite a lot of tricks, even using Cinega, for example. These are how much it took to train the different model sizes of Minerva on the Cinega supercomputer. And you can see that to train Minerva 7B, it took almost 3 months on 32 nodes. And using basically 4 times 64 gigabytes of custom A100 for each node. Okay, so I'm a bit late. What is interesting is that we need to invest again on this kind of large language model. You can see here the evaluation of Minerva while it was training. It kept improving. So if we go on, we enlarge the amount of data and the amount of parameters, most probably we will end up having better models. So it's not something that is done. It's something that we have to build upon. Okay, this shows the evaluation of our models with respect to other models. You can see that for 1 billion models, we were pretty competitive with the others. With 3B, actually, we outperformed most of the competitors. And for what regards the 7B, we had very good performance even compared to proprietary systems like Llama 3.1, that is a multilingual large language model. Okay, these are the strengths and the weaknesses of Minerva. And one key takeaway is that when we talk about instruction data sets, we don't have many. Okay, so if we compare our performances with respect to closed source models like Llama 3.1, of course, we fall behind because these kind of systems have a lot of data, a lot of instruction training data that costs too much for our academic budget. But if you go on benchmarks that are not that used for instruction training data, you can see that Minerva, for example, can translate better than most of other models out there. Of course, we trained even an instruction-based dataset. You can see that our model falls behind when we test it again instruction-tuned dataset like Llama 3.1, and that's exactly, I think, what we should invest on afterwards. And that's all. I mean, we safety tuned it, and I mean, there's a lot of research here after Minerva. Thank you for your attention. You can find, you can try Minerva on the website. There's a paper published at Kikit, and of course you can use all the models on and download it from Agitface. Sorry, I was a bit slow on the starting. We are still using human-generated data. So the first iteration of Minerva Instruct was trained on dataset that were human-based, basically. Most probably the second version of the second instruction fine-tuning will be on synthetic generated data. So the next generation of Minerva version 2. I mean, otherwise we won't be competitive with current models. So I should talk like 15 minutes on this question. Problem is, at the moment, if you use benchmarks to evaluate large language models in Italian, you will end up, I mean, you won't end up having a fair evaluation. And that's because, for example, Mistral, that is an English model, performs better than most of our Italian models on Italian benchmarks, because the way we evaluate those models is, I mean, not the way we should. And if you try to use Mistral in Italian, he cannot even speak Italian, because we use multiple choice selection for evaluating these kind of systems with perplexity-based metrics. This doesn't work. So what we should do is improve the evaluation. If you use Minerva on the website, you will, I mean, be able to talk with Minerva and, I mean, have a chat that is basically on par with other models that are pretty much English based. For when I say in the same ballpark, for example, on a lot of stuff like machine translation, we perform even better. On knowledge based benchmarks, we perform better than most of other systems. Of course, 7 billion parameter system. I mean, if we compare with bigger models, we are not in the same ballpark. I hope I answered the question. Thanks a lot.
The next speaker is Danilo Croce, enhancing context-aware human agent interaction with multimodal AI.
Hello, everyone. Hope you can hear me. I'm Danilo, and I would like to introduce the activity and the results of a project, a Cascade called funded project that is called RAMSES. So what are the objectives of this model? Actually, is to develop a framework for multimodal AI. And I would like to focus on the problem of human-robot interaction. So in our idea is that AI agents that can be physical or not have to, in interaction in a real or realistic world, have to interpret what they can receive from the environment, reason, decide, plan, and then act according to the request of the users. How to do it? We would like to use and study a recently proposed multimodal large language model in order to integrate perception, language, in order to plan the interaction. So we want to enable what is called context-aware dialogue. So actually, let's say what was used before this kind of project. As you have seen before, I thank Simone that introduced the problem of semantic relabeling. If you have a question, now I will focus on Italian, but the idea is take the book on the table near to the window. So prendi il volume sul tavolo vicino alla finestra. You can have from the robot or the agent the perception, so it can be represented in the knowledge base on whatever representation you want in your agent, in order to detect and retrieve which entities are mentioned in your presentation, in order, let's say, what was used to, if you want to use and reuse a large language model, generate a linguistic description of your word in order to, let's say, combine with the input in order to have enough evidences in order to translate it with some commands that can be used, for example, to simulate your planner. So our research group actually already was working on this kind of topics. And what it happens that we were already working on image and video captioning and visual question answering, even before that GPT was released. And you can, if you're interested, you can also find some resources that are cross-lingual in Italian and English for the captioning of images and video in Italian and in English, or for playing with the problem of visual question answering. So in this project, we want to enhance this kind of resources in order to capitalize the information for use them in human-robot interaction. So we want to use and reuse this information in order to generate images. We have seen before that we can be interested in real data or synthetic data. We can have data that has been manually annotated or data that can be aligned with the request on existing data set that already exists only on the linguistic level. So we want to obtain what we call augmented images that has been can be extended and assign metadata that provide additional information or use large language model in order to somehow certificate or filter out images that can be automatically generated and maybe they are consistent or hallucinated, in order to use it safely in a context with human-robot interaction. So the idea is that we want to study and the applicability of multimodal large language model in this scenario, and also to investigate the relation between images, so perception, what is the grounding, so the relationships with the linguistic level, and the problem of planning. That is not just to plan the actions that the agent have to decide, but even to plan the interaction that maybe the agent need to provide in order to really understand and avoid to misunderstand what are the requests of the users. And what to expect at the end of this project to provide the results and benchmarks in order to improve accuracy, interpretability of this kind of context-aware interaction in a multimodal framework. And okay, this is the roadmap of our project. We are at the beginning because it started a few months ago. And in the first part, we are focusing on studying the quality of state-of-the-art multimodal large language model in facing specific tasks like visual question answering, because we think that visual question answering is a way that we can use to interact with the resources in order to discover if they are consistency or not, and to study the capability of this model in order to support planning, especially in the interaction with the users. Here we just want to provide the idea of what we are doing. We are in a synthetic world, like in a sort of Minecraft, and the agent and some kind of perception of the world. So you see here some 3D blocks that are providing your world. And then you have the agent that is the builder, and then you have user is the architect that want to build something. That, for example, we have two commands. I don't know if you can read them, but at each end of the orange row, place one red block. And given the perception the robot is an agent is expecting to accomplish this task, to plan what is needed for this action. And in the other case, place two red blocks on the leftmost red block And the robot actually can not have enough information in order to execute this action. And we can expect the agent to answer, not to act, and to answer which direction is the leftmost facing, east or west, because it does not have any enough information. So to understand what we would like to do is to apply multimodal large language model that actually combine the capability of visual encoder in order to take the image, for example, with that visual transformer to encode. All the animation are not working very well, but imagine all these blocks that are provided and encoded, and then to apply a sort of projection that allows you to reduce the dimensionality of the encoding in a way that can be somehow made compatible with the input, so the embedding that are provided in input to your language model. So the idea is to make the language model that can be dependent on the information that obtains from the vision counterpart. And the output, the animation not working, is a text. In this case, the text is the answer. For example, I can accomplish it or I cannot accomplish and provide the answer. So what we are working now, you see on the right, you have a request, and we would like to study the capability of this model also to plan the type of interaction that it requires, because maybe you just don't need one kind of information. For example, here you can see also some blocks above the easternmost purple column, and then the actually is not really complete as information, but you require possible several interaction. For example, you see that the agent is asking how many blocks you want, which color, see if the color are not allowed, which other color are available, for example, on which direction, and so on. So here there is that add the capability of planning, like you have seen, for example, in these days at DeepSeek, the capability of models, large language model, improves when you start by planning what you need to do. And in this case, we would like the language model, the visual language model, before providing the answer, to plan the sequence of information that are required in order to achieve a possible goal, and provide this plan that is generated directly from the large language model to itself in order to start asking, and at each turn replan in order to improve the quality. We obtained so far interesting results, improving the quality of the dialogue itself, demonstrating that if you train a model in English and you apply in English, you have a quality that actually can be the same in Italian. But if you apply cross-lingual analysis, so you train on English and you apply on Italian, multilingual large language model works, but actually you are not able to have a good quality of generalization without a planning. If you introduce the planning again, you have the same results on a model that is trained on English and applied in Italian, the same quality of a model that is trained on Italian and then applied to Italian. And what are the next steps? We would like to investigate the capability of models that generate artificial words that you see now. Is it real or not? And is not real. And the idea is to, if you want to execute a command like here, take the smartphone on the table and switch on the TV, we would like to have the interpretation like we have seen on before in semantic labeling style, by grounding at the same time the entities. And the generation is quite, it's possible, it's very interesting, but the problem is that generating words that are not consistent with your command can be very dangerous. So there is still some work to do. So thank you. If you're interested, I don't know if these slides are available. I provide the bibliography of previous work and the resources that I've shown so far. So thank you. And even to say thank to the collaborators, because it's not only my work.
No question for this session, just for the
Okay.
Thank you. For the presentation of academic partners and so on, no questions. So, the next speaker is Andrea Cosentini and Francesco Bonazzi from Intesa. This one.
Thanks a lot. We have two different research line in our commitment. A few words about the first one. The first one is related to a mandatory constraint of the European regulation on artificial intelligence act, that for a part of the high-risk systems require fundamental rights impact assessment of the artificial intelligence systems. So we implemented a tool that perform this impact assessment. We are finalizing our tool, our research. It is composed by two different parts. A questionnaire that provide a questionnaire risk indicator, and the quantitative matrix that provide an impact significance for every fundamental rights. Fundamental rights obviously are 50 in the European Charter. And the combination between the questionnaire and the matrix provide us the fundamental rights impact assessment score for every right. This is here a few details about the questionnaire and the matrix. But for this research line, it's all, and the floor now is yours.
Okay, hello everybody. I'm Francesco Bonazzi. I work for Intesa San Paolo, and I will present you the second project that our company is conducting, as Andrea mentioned. So this is about creating a data set for retrieval augmented generation evaluation in the Italian language. So what are we doing? So we decided that a typical commercial approach to retrieval augmented generation is, and a use case that we have a lot in our company is the necessity of data extraction from balance sheets. I mean, you know, balance sheets are the statements that are yearly drafted by companies and published. They contain certain information. There are some international standards and requirements, legislative standards that require companies to report a certain set of information. Unfortunately, this is just natural text. I mean, every company writes this information in text. They put many tables into it, graphics, stuff, and so on. Though these contain pretty useful information that even that could be extracted. So what did we do? We decided to start with large companies, especially the ones that are traded in the stock markets, because the balance sheets have to be published on there. These are pretty standards. I mean, some companies create their own balance sheets with personalized, customized structure layouts. Other ones go to some consulting companies, and I mean, especially the small ones, they just go to a consulting company and they fill out the just simple documents. Anyway, what's important is that we have a variation of documents that contain mostly some data that needs that would be nice to extract. This is also in view of analyzing the balance sheets of smaller companies, maybe not the ones that you need to go to the Camera di Commercio to have, and stuff like this. As I mentioned, that data may be these PDF documents usually have complex data, so it's not just about analyzing the text, it's also about analyzing the layout. So what did we do? We created a set of about 50 questions that contain common question about, for example, who is the CEO of the company, who are the members of the board of directors, who is, what's the annual turnover, annual income of the company, and these things. And we created some two types of retrieval augmented generations in order to test this data set. We created first a simple retrieval augmented generator to find, we selected some powerful open OCR system for open source OCR libraries to test them. First, unstructured, which is a library that implements OCR plus various layout analysis tools and layout classification of tools, plus some specialized models to recognize tables and stuff. And after that, when Docklin was published this autumn, we switched to Docklin. So we take these documents, we chunk them, create blocks, logically classify the blocks of text. After that, we did a simple RAG, and we created a simple JavaScript tool to visualize these results and correct them by hand. So this resulted in the let's say in the creation of let's say a corrected data set. At this point, this is just to show you some of the structure that we typical graphics that we have. These information, sometimes information is put into these charts. So we ended up with a data set of correctly retrieved data, and we generated data to confront, and then we are now approaching the problem in two ways. A simple RAG on text with a RAG on text approach by using OCR and layout analysis tools and classical standard, then which is evaluated at the end by metrics both on the retrieval side and on the augment generation side. And the other approach we are currently pursuing is without doing any OCR at all. We just extract chunks of images from these PDFs, and we create some retrievals based on multimodal embeddings. Similarity between embedding of text and embedding of images, vision embeddings, and the answer is generated at the last step by a vision language model. So this project is ongoing, and well, if you have any question, I'm here to answer. No questions? Sorry, I didn't understand. Okay.
Okay.
Not entitled to receive questions.
Yes, correct. Next, we have Alessio Miaschi from CNR. Controllable text generation for evaluating large language models linguistics competence. You have 10 minutes plus 5 of questions.
Okay, the slides are. Okay. Lo scaricare, no?
Okay, so hi everyone, I'm Alessio Miaschi from the Institute for Computational Linguistics at the CNR in Pisa. And this is a work that we entitled Controllable Text Generation for Evaluating LLM's Linguistic Competence. And I would like to start with this slide from a previous presentation of the Spoke 5 of the FAIR project, where, I mean, the focus was the idea of developing measurable qualities for the assessment of AI systems, with a specific focus on natural language generation and text quality assessment. So the two works that I will be presenting here are works focused on the evaluation of LLMs, and specifically on the evaluation of the quality of the generation of these models, with a specific focus on the linguistic abilities of these models. I will start with this work that we presented last year at the MNLP. The motivations behind this work are that large language model demonstrated remarkable capabilities in solving multiple tasks, but also in creating coherent and fluent texts. And these capabilities have been studied in several benchmarks, several datasets, several tasks, but a comprehensive evaluation of the abilities of this model in generating coherent and generating linguistically coherent text is still missing, independently of specific tasks and possibly cross-cutting among them. So we ask ourselves how effectively the large language model can generate sentencing adhering to specific linguistic constraints representing different morphosyntactic and syntactic phenomena, and understand how they behave in generating those kind of sentences. So our framework was quite simple. We evaluated the ability of LLMs to generate sentences adhering to different linguistic constraints. The idea was to simply prompt the model to generate sentences containing constraints with a fixed prompt structure. So asking the model, as you can see here in the image, to generate, for instance, a sentence with 3 verbs, or generate a sentence with 1 subordinate preposition, and see if the model was able to correctly follow these constraints. And since we know that these models have difficulty in producing tests with precise numerical constraints, we decided to constrain the models on increasing values of these linguistic properties in order to see if the model are able to follow a trend of increasing values of a specific linguistic property. I will not spend too much time on this slide. Here is simply the setting of the experiments. We extracted the values of these linguistic properties from the universal dependency tree bank on the English language. We selected a set of different linguistic properties to prompt our model. And at the end of this process, we asked the model to generate 50 sentences for each specific value in a set of 5 values for each linguistic properties, obtaining at the end of the process 250 sentences. So to be more precise, I will show you in the slides with the results, the kind of properties that we asked the model. We tested these models at different parameter sizes and different architectures. So Gemma model to be a 7B, Llama 2, 7B and 14 billions, and the Mistral model 7 billion parameters. And used 2 different evaluation metrics. The first one is the success rate, so it's simply the accuracy of the model in precisely follow that constraint. And the second one, we compute the correlation between the ability of the model of predicting this increasing value of linguistic properties to see if the models are able to follow an increasing trend of increasing linguistic properties. So here in this slide, we have the results in terms of Sperman results. So we have the models, we have the configuration in terms of 0-shot prompting and 5-shot prompting, and we have the different linguistic features that we tested. So features related to the morphosyntactic structure of a sentence. So for instance, generate a sentence with a certain numbers of verbs, nouns, punctuation, and so on, and more complex features related to the syntactic structure of a sentence. So for instance, the distribution of the subordinates in a sentence, the position of the subject or the object in a sentence, and so on. What we noticed is that the best performing model usually are the bigger ones, even if the best performing model is Mistral, that is smaller with respect to Llama 13 billions of parameters. And we noticed that in general, the models are more able to follow morphosyntactic constraint than syntactic ones, so they have struggled in replying to correctly generate a sentence with a specific, more complex syntactic constraint. And these are the results in terms of success rate, so the ability to precisely follow that constraint. If we focus on the results in terms of Spearman correlation, so see if I'm asking to generate sentence with increasing numbers of verbs or nouns, etc., the model is able to follow this kind of trend. And as we can see here, the results are quite higher with respect to the previous one. So that means that even if a model is not that precise in predicting or generating a sentence with that specific property, is somehow be able to follow the trend in increasing this kind of property. And this is basically what we did in this work. And since, I mean, one of the focus of the third project is also focusing on the Italian language, we perform a spin-off of this work for ClickIt and evaluating Italian models. We specifically evaluate the 6 Italian instruction-tuned models that were available at the time that we performed the experiments. And we also add another step in this kind of evaluation process. The first one is the same one that I explained to you before, so asking the model to generate sentences with a specific constraint. In the second one, we performed a validation step. That is the idea that we took the sentence that the model generated and asked the model, for instance, how many adjectives this sentence have. So to understand if his model is able to understand how many adjectives or verbs or nouns are present in a sentence, and if there is somehow a sort of consistency in the model, in the generation phase and in the validation phase. So these are the results of the generation phase, in which we notice that the best performing model is the Anita model, while the worst performing ones were the Italian model and Camoscio model. In general, if we performed on a small amount of properties, the results are quite in line with those that we find on the English models that we tested for the NLP work. But the most interesting results for me are those related to the validation setting. Here we have two different configurations, the one that we call the constraint and constraint plus. The first one is the consistency or the validation step reported for all the sentences that we tested in our experimental framework. And in the second one, we used only the subset of sentences that correctly match the asked linguistic constraint. So basically, we took only the sentences that the model correctly generated in the first phase. Well, what we noticed is that, of course, in general, in the second configuration, so when the model was quite able correctly to generate sentences with a specific linguistic constraint, the model was much better in the validation in the validation phase. But we noticed some different results, and I sort of have some selected findings of these two works. The idea is that models are more able to follow morphosyntactic constraints and are able to distinguishing, especially when we are asking to generate a sentence with or without a specific linguistic properties. We notice that when we constrain a model to generate specific elements, we don't only modify that property, but we modify the entire structure of the sentence. And more interestingly, for the validation phase of the second work, we noticed that when validating the model against their own generated sentences, we noticed that the generation ability does not always align with the ability of the models to recognize these linguistic properties of the generated sentence. So there is a sort of problems in the consistency of the models in the generation and the validation phase. And so, I mean, LLMs have reached astonishing performances. They are able to solve a lot of tasks, but there is significant progress to do. Some future directions, for instance, using and applying this framework and evaluating the generalization abilities of these models in different scenarios, domains, and languages. And another point that I wanted to mention here, because it's part of a work that we just finished and submitted to a conference, is the idea of analyzing and controlling the linguistic profile of generated text to develop more robust machine-generated text detection systems, with the idea that if we can somehow modify the linguistic profile of generated text to be more human aligned, then we can somehow full machine-generated text detection systems and make the task more difficult in order to give insights for the development of more robust machine-generated text detection systems and machine-generated text benchmarks. Thank you. Yep. This one, okay. Okay, yeah. This one? No, this one. Okay, okay, yeah. Yeah, yeah. We perform some experiments using different prompts, also because we know that models have some kind of problems in dealing with different prompts. We can notice different results. There are some kind of differences in terms of performances, but focusing on the relationship between models, the rankings is quite similar. Even if here we are doing some other experiments for extending this evaluation also to different domains. So for instance, asking the model to generate sentences on specific domains or using different kind of formulation of the prompt to see if there are differences in the ability of the model to follow correctly the constraints. Thank you. Thank you.
Is Misael Monjovi. Okay. Controllable large language models by enforcing grammar compliance.
Thank you. Hi, everyone. I'm going to present a work about controllable large language models by enforcing grammar compliance. By controllable, we mean that we want a guarantee on the output of large language models. So, first of all, why this work? We know that large language models are great, but they still have some limits. And for example, one important limit is that we don't have any guarantee of the on the generated text. And sometimes we want some guarantee. For many applications, we want, for example, to enforce some specific syntactic structure, or we want to adapt to specific taxonomy, vocabularies, or constraints. So to show that, I want to show you an example. This is a real example. We asked to a large language model to solve a task, a classification task, a simple classification task. It's actually a hierarchical classification. So the hierarchy is in two levels. The first level is the domain. We are classifying scientific abstracts. So the first level is the one of 7 domains, and the second level is the area, one on 140 areas. And we ask just to classify that, and we give the whole taxonomy. And we say explicitly that it has to answer with the most appropriate label. So we tried with llama 1 billion parameters, and this is what we want from this example. This is the gold class, and this is what we get. So the model don't follow the instructions. We can use a bigger model, so we tried with the llama 8 billion, and this is okay. This is what we get. It's much better than before, but we have the repetition of the domain. So medical and psychologists are first level of the taxonomy. So still, this is not in the format that we want. Okay, so we tried with Llama 70 billion, and it's better than before, but we have a domain followed by something that is not an area. So it's not following the structure. It's not giving an area of the list. So even the better model we have, this is a model that needs an important hardware to be computed. This model does not follow the structure. So we sometimes want, we have reason to want that the model exhibits certain, that the output exhibits certain characteristics. For example, restricting the output to fixed vocabulary, to adhering to a specific syntax, and so on. So what we can do, we can act on the coding part of the large language model. So the coding is made in this way based on the previous tokens. We compute a distribution probability for the next token, and we need to change this decoding by adding a component that checks the valid tokens. So before generating the next token, we just cancel out from the distribution the tokens that are not valid. Okay. Oh, sorry, I went. Okay, so this is the component that we add to our large language model. It has two functions. One to get the valid token for that timestamp, and it needs to have a state that needs to be updated at every token generation. This can be done by a fin state automata, but fin state automata can only support regular languages, so are very limited. We want to support a higher class of languages, and we have something from the literature that is formal grammars that we can use for this. But first, let's look at some desiderator. We want to express the constraint in a formal way. So natural language is not okay. We want a formal language to be sure that it's unambiguous. We want integrability with the large language models. That basically says that we want to support the left-to-right processing. So because this is the way how tokens, how the text is generated by LLM. And we want our system to be versatile. That means that it's capable to describe constraints. The user needs to be able to describe constraints in an easy and expressive way. And we want it to be efficient. That means that we want it, the overhead that we add to the LLM need to be linear in the size of the input. So we can use, as I said, formal grammars. Here is an example of a formal grammar used for hierarchical classification. So basically, we specify the list of possible domains. Sorry, so, for example, by chemistry followed by chemical area, where biochemical area can be cell biology, DNA sequencing, and so on, or civil followed by civil area. That here we have the possibilities for civil area. So this is just an example on how the formal grammar can be defined. So very fast, we cannot use the whole class of formal grammars because it's not tractable. So we have two possibilities. One is to use CFG grammars that are versatile but are inefficient. They cannot be implemented in an efficient way. Here we have an example, an approach that has superlinear complexity. On the other side, we can use LL1 grammars that are efficient but has limited versatility. So we came up with another class of grammars that is called LL prefix that is more versatile and it's adaptable to large language models and is also efficient. So it can be evaluated in linear time. Just to make an example, this is a very simple example of a grammar that we can use where we are saying that the output must be one of these two words. If we consider these words as terminals, that we can assimilate terminals as tokens, this is a LL1 grammar. But since we have tokenization, we can have subword tokenization. So we have to express the grammar in this way, and this is not an LL1 grammar. So what we did was to define a class of grammars that overcome this limit by allowing on the first part of the right-hand side to have any sequence as long as we want of terminals. And we have a way to transform this grammar to an LL1 grammar. And okay, maybe I ran out of time. So this is basically our pipeline. From the LL prefix grammar, we produce the LL1 grammar, then the PDA, and we do constraint decoding in the LLM. I just wanted to show that we have results in 3 use cases, and always we have results that are better than the baseline. So basically, with Llama, with 1-shot, 2-shot, and so on, we always have results that are better with our decoding model. Okay, that's it. Thank you very much for the attention. Because L1 are evaluatable left to right. So this is the a natural choice for integrating with large language model where we have to evaluate token by token. Okay, it might be an alternative. Okay, but still, when we try to integrate with a large language model, the problem we have is that what we consider as a terminal. I mean, we want to express long strings that are tokenized by several tokens. So yeah, we cannot do this with this kind of grammars. So we need a higher class of grammars. Thank you. Thank you for the question.
The next one is Lorenzo Marconi, a gentle introduction to controlled query evaluation in the DLI ontologies. 10 minutes plus.
Thanks, Federico. So, hello, everybody. My name is Lorenzo Marconi, and I'm going to give you an introduction in controlled group evaluation. And at the end of the presentation, I will also briefly discuss our last work that we, as already anticipated by Riccardo Rosati, got the award at the HCI conference of last year. Can I use the note? Okay. So controlled query evaluation is an approach to query answering, purely declarative, oriented to data protection. That was introduced for databases in the 80s, and more recently, let's say in the last decade, was also studied for description logics ontologies. The key role is played by the policy that is a set of logical formulas that one uses for stating which data should be protected. And also the notion of sensor is crucial in controlled query evaluation, since it's the tool that we actually use for enforcing the protection policy. In particular, as I was saying, we talk about ontologies, the description logics ontologies. So we, as a standard, we have a T box for representing the intentional knowledge, the A box for representing the extensional knowledge, so our, let's say, ground truth. And also we have a policy that, as I was saying, that is usually made of denials that are expressions like this. So we have an implication whose body is a Boolean conjunctive query. And our aim is to let a user pose queries to this ontology in such a way that the end user is not able to infer the body of the denial. So this body of the denial is what we want to hide to the user. So the notion of sensor here is crucial because it is a set of logical formulas that are all logical consequences of our original ontology, and at the same time does not violate the policy P. So it is, let's say, a safe view that we have, that one can expose of the ontology. In general, we can have many possible sensors, as we can see here in this example. I forgot to mention that a sensor must be must contain formulas expressed in some language. Okay, we usually take, for example, the language of ground atoms that are atomic formulas without variables, but they can also be BCQs or whatever. In this case, we consider ground atoms, so we have, for simplicity, an empty T box, an A box containing just the fact that O is both instances of A and B, and our policy states that we should hide the fact that some individual is both instance of A and B at the same time. So this A box clearly violates the policy intuitively. And so we can enforce the policy by either hiding B of O or A of O or both of them, obtaining these three sensors. Anyway, in general, we are interested in optimal sensors that are the maximal ones with respect to set inclusion. So, for example, in this case, we just take A of O or B of O and not the empty set. This is a, let's say, more complex example. Say that we want to protect all the people that are cured by someone that has a specialization which is oncology. So all the people that may suffer of cancer. And from our T-box, we know that everyone that cures someone else must have a specialization. Everyone that is cured by someone else must be an instant of patient. And in the A-box, we know that Bob is cured both by Anne and by Chloe. And we know that Anne is an oncologist, okay? So we can, this A-box clearly violates the policy, since we know that Bob is cured by someone that is an oncologist. And we have many possible ways of censoring our information. These are three possible ways. Anyway, notice that only the first two are optimal, because in particular, sensor 3 is a subset of the first sensor. We are taking, again, sets of ground atoms, okay, in this particular example. And so one can see that C1 and C2 are the only optimal sensor that can be built using just ground atoms. Now, consider these three possible queries that can be posed to the system. The point here is how should we answer to such queries? We should agree on a formal semantics for answering these queries. Intuitively, one can say that that revealing the fact that Bob is a patient is safe, right? Because this fact both belongs to the first and the second sensor. And maybe the same can be said about the second query, because in the second sensor, we know that N has a specialization oncology, and we are asking whether N has some specialization. But also in the first sensor, we know that N cures Bob, and from the T box, we know that everyone that cures someone else must have a specialization. So maybe also to the second query, we could answer yes. But what about the third query? This fact N cures Bob only belongs to the first sensor, and the second sensor doesn't provide any information for answering true to this query. So we should agree on a clear semantics for answering such queries, and there are indeed some reasonable semantics under which this query can be answered true. So what we study in this framework typically is the computational complexity of answering queries. Once we have agreed on the specific query answering semantics. And also we study other formal properties that can be enjoyed by our framework, obviously related to confidentiality preservation. And we move on several orthogonal axes, such as the description logics that one may use for expressing the T-box, the language used for expressing the sensors, and also the language used for expressing the policy. So the rules that we use for censoring the data can be denials, or can be also other kind of logical formulas. And finally, obviously, maybe the most important thing, we should agree on which is the semantics that we use to answer the queries. In the example before, we said maybe a possible reasonable semantics is to answer true to a query if and only if the query is true according to all the sensors. But there can be other semantics that intuitively are well-founded. Now, for concluding, I briefly mentioned our last work on this topic, that is enhancing controlled evaluation through epistemic policies, in which we indeed proposed the usage of epistemic dependencies as alternative to denials. Indeed, epistemic dependencies are an extension of denials, which are syntactically more complex. As you can see here, I will not obviously give a precise explanation because of the remaining time, but I will just give you an intuition in the next example. We considered the CQ sensors, that are sensor containing BCQs, in contrast with the example that we saw before, that was using sensors made of ground atoms. And for what concerns the entailment semantics that we studied, there are both the skeptical entailment, that is the one that I was mentioning before. So a true query is entailed under the semantics if and only if it is entailed by all the sensors, all the optimal sensors, all the optimal CQ sensors in this case. And also we studied another entailment semantics that says that a query is entailed if and only if it is true, if it is entailed by the intersection of all the optimal sensors, which is not the same as actually as the other entailment semantics. So I think I will skip this example because we are running out of time, but just for give you an intuition of what epistemic dependencies are, here we have both a denial, that is the second rule, but maybe the most important rule is the first one, which is the epistemic dependency. Here we are protecting all the people that are patients and have been admitted to some hospital departments. So the main differences with denials are two. The fact that we can both use existential variables within the scope of an epistemic operator and universally quantified variables outside the implication. And the second thing is that we can use also DCQs in the head of the dependency. So, but what does this mean? Here we are saying that for every patient, okay, we are hiding the fact that there exists a department in which the patient has been admitted to. So we are not hiding the existence of patients admitted to departments, but only the identity of the patient. And also here, the head of this dependency plays the role of the exception for the dependency itself. Let's say here we are saying that this rule should apply only if, should not apply if the patient gave its consensus for, let's say, this data to be published. Okay, I will skip this part. And finally, briefly mention that in this case, the data complexity of the two entailment semantics is co-NP. So the decision problems related to these entailment semantics are co-NP complete, actually, in the case of arbitrary epistemic dependencies. Whereas in case the policy satisfies a specific cyclicity condition that I'm not describing here, the problems become first order writable, and so they are in ACID 0, which is a subclass of log space. And also we studied an interesting confidentiality preservation property that also here I'm skipping for reasons of time. And these are the references that I mentioned in this presentation, and thank you all for your attention. Not yet, but it could be interesting. Thank you.
Okay. Maybe it works now. Okay. The next one is the next speaker is Ognjen Savkovic. Okay, thank you. He will talk about a joint project such that Bolzano won an academic cascade call.
Right. Hi, everybody. So my name is Ognjen Savkovic. Okay. So I've been asked to give this talk, even though I am still learning about the project, but I will try my best to explain what is this about. So I don't have such a great results as we've seen today here, but my idea is to give you the gist what we're actually doing and how we're progressing. So the title of the project is Implementing High-Quality Virtual Knowledge Graphs. So let's hope you can understand, okay, implemented, it's clear, but let's hope we can understand what is virtual knowledge graphs and what we plan to do. So I'm coming from Bolzano. So you know Bolzano, this is the photo, right? We have there mountains. And you can just call me Ogi if you want to address me, because first name is very difficult to pronounce. All right, so few things that I want to address today. So I will try to give you a very crash course on the virtual knowledge graph. So I think it's a mixed audience, so probably some of you already know these things very well, so maybe I might be very boring. But anyhow, I thought maybe it's worth mentioning. I will give some objectives that we have in our project, particularly related to these virtual knowledge graphs, and then I will just specify 2 things that I'm excited to work on this project here within the team of Bolzano. All right, so generalizing story a little bit. So we have this problem of big data. That's how we come into the picture. So probably for many of you, this is very familiar. So you have data which is not only about volume, but it's about a variety of data. Then the velocity, how the data coming into this. So some data come sooner, some data come later, so forth. I don't know even how do you pronounce this, veracity of data. So basically means that some data is more trustworthy, some data is less trustworthy. So all these kinds of things that you have with modern data management as a task. And as a modern, let's say, problem, we have a modern complex solution. So this is the very popular solution. It's called knowledge graph. So it's something which everybody is talking in different contexts. Maybe not as LLMs, but let's say in our limited bubble of data management, knowledge graph is a very fancy word. But in this case, it can be materialized, which is like physically existed, you can touch it, and or can be virtual, so which means you cannot touch it. It's you can query it, but you cannot touch it, so it's not there, it's not stored. So how does it work? So basically, at the bottom you have this so-called data sources. So in maybe the most traditional setting, you can think of this as a relational databases. You can think this is just a few of those that you want to integrate. So classical data integration problem. In the more modern setting, I would say this is not anymore only the relational databases. It could be any sorts of files, let's say maybe CSV files, any semi-structured data, whatever people now put data into, JSON and so forth. And there is a connection between our, let's say, virtual knowledge graph and these data sources via mapping. So this is the key part, which is usually not present in many scenarios, so not considered, but here actually it's very important because also depending how this mapping is expressed, you can do different things or not. And on the left-hand side, we have this access point, which is basically the users. Now, again, traditionally, you can think of this as basically Sparkle queries or SQL queries or some kind of very personological format queries, right? But nowadays, you can think of it as any other things, like you can have different, let's say, tools or languages to access the data depending on the preference. It can be graphical querying and so forth. And at the end of the day, me as a theoretician, I would think of this as some sort of a first-order logic query or second-order logic query or data log and so forth, but in practical application, these can be different things. Okay, so let me try to a little bit motivate the details. So why these settings could be useful and what is the advantages of such a, you can say, oh, well, that's very complex. Okay, some things are good, some things are also need to be paid for. So in particular, why things are done with this so-called knowledge graph? Well, many of the data which are kind of dynamically created and going on the fly and changing the structure all the way. So knowledge graph allow you this nice property that you don't have to commit to a structure. So you can keep your structure changing all the time. So I don't know how many of you are working with database, but database you have to fix your structure first, and then that's it. So you have this for forever. So changing will cost you a lot of money, effort, and so forth. This knowledge graph, you can dump everything in, very easy. Okay, there is a hidden caveat we talk later, but at least we can start with something. Then as a vocabulary, you can use this all languages for ontologies, whatever language you use, maybe OWL, maybe RDF, or even nowadays you have these property graphs, which is another nice format for all this knowledge graph, let's say, description. And another nice thing about this knowledge graph is that it naturally addresses the missing data, because the missing data means you simply don't put it there. So in the table, in the classical SQL, you have to put the nulls, you have to think what the null means. It's also unclear if you think about it, but here it's not there and it's fine. We also have this drawbacks, but as of now, we just talk about good things. Then we have this mappings. So this thing which I talk about, which is this connection between the sources and the graph. And usually this thing, if you have some, let's say, complex integration thing,
this thing would be done in some maybe Java code, or it would be done ad hoc, and who knows how we can interpret this. So a new person comes, he has to read this code and so forth. Our idea here, or our idea, I mean, this is already classical idea for knowledge graphs, is this should be done with some declarative specification. There are already languages proposed by the W3C standard, how to do that. And these languages are very formal and declarative, which in turns means that you can use them to optimize the whole process of querying, which I'll come in a second to. And finally, which is maybe the most complex bit of this whole setting, is this virtual keyword. What does it virtual mean here? Well, virtual means basically the data is not there. And how are we going to access the data? Well, we're going to access the data at the point of request. So you come as a user, think of you as you want to write SQL query, you write your SQL query, we take your SQL query, we look at this virtual thing, and then we basically, as if data is there, so the user maybe doesn't even have to be aware of it, actually ideally shouldn't be aware of it. This query is kind of rewritten, that's what we call rewriting, or sometimes even perfect rewriting, if you heard this term, back to the sources. So this kind of, that's where the declarative part of the mapping comes into the play, where you basically rewrite this whole thing that you asked, maybe your SQL query, back to your sources while mapping. So it becomes one gigantic awful query at the end, but you don't care because there are some very smart systems, potentially database system, which can handle this very efficiently. Okay? So why this is advantage again? Well, advantage is because now you don't have to materialize the data, you will have always the freshest data, right? So your data is always the best possible, right? Because you don't have to constantly update the data, because for example, with a Wikidata, it's constantly being updated from time to time. So here you don't have to do that. Obviously, there is a price to pay, and it's a kind of always pros and cons. Price to pay is now you have to have we call this logical inference. Basically, query answering will be a logical inference. Well, it could be very complex logical inference, and there has to be done a lot of work to optimize this inference, so you don't get queries which can basically clog the whole process. Okay, so this is the crash course on this part. I hope I managed to convince you this is good for something. Just to say, in Bolzano, currently there is already a system that is doing this. So it's called on-top system. It's a state-of-the-art system. In particular, it's not as general as I described. It is very specific to the semantic web standards. So it uses RDF, RDFS, AutoQL, R2ML for the mapping language, and Sparkle as a query language, and supports major database, let's say, formats for the data sources. And this setting we want to extend it further. In particular, in this project, the goal is to extend this with non-relational data sources. So you can think of any other popular non-relational source, which further implies the other things that need to be changed. We need novel techniques for query processing or optimization. Also new implementation techniques, so depending of what kind of source we are having. And in addition, we want to, which is always actually one of the issues which we always have, is how to facilitate this process, because this is nice if you have it in place, but somebody has to design this complex setting. And we would like to use some AI-based methods to design this setting, this virtual knowledge graph. And we also want to make sure that we can ensure data quality on top of it, right? Because as I said, this lack of structure means sometimes also lack of quality. But sometimes you want to know what is the quality there. Okay, and if I have 2 minutes more, I can briefly just tell you what I would like to work on this as a topic here. Okay, so this is the jaunt of the project. Maybe that's not important, but what is meant for me at least interesting, and if you have any comments, I'm happy to discuss with you. So we look at basically two problems so far. This is ongoing work. One is about addressing the problem of integrity constraints, so core keys. Okay, integrity constraints is more general term, but let's say keys is more specific. So we want to actually look at the keys, which are basically like a major building block if you think of terms of data quality. So I'm thinking here as a key in the most general setting. So some of you may be aware that recently there was relatively recently, there was a shackle standard which is proposed by W3C for assessing the integrity constraints over the RDF data, which I think now
is even in the phase 2, they want to update the standard. This is something which is getting a lot of popularity. Actually, I would believe even now getting more and more use than owl. You have a similar situation in property graphs. If some of you are aware, there is a new standard from schemas for property graphs, again, for the purpose of doing the quality check and ensuring the structure of the data. But me working on this topic with this property graph group, I also realized that actually how important for many these core data management people, the concept of key is the data. So you can think, I don't know, key is something like every person is uniquely identified by their codice fiscale. But actually, it's also the way not only how to check the data, but also how to describe the data, because as I said, this lack of structure is also very important. Right, so here, just to make sure, so the idea is to study keys in this setting. So how to reformulate the keys. Again, keys, as anything else, has to be rewritten back to the sources and rewritten and so forth. That's one thing. The other thing, which I know a little bit less, but some of people here maybe know more, it's about virtual T boxes. Basically, not only the data can be virtual, but also basically your T box could be virtual, meaning that you don't know the name of the concept that you're going to materialize. So concept is stored actually also in the data. For example, all sorts of apples are stored in the database as a database column. And there is already some work, we call them in Bolzano Romans, but maybe here it's generic, on meta modeling, meta querying all to QL. So basically a way how to deal with this problem, but without the mapping. So with the question of mapping, this is still kind of an open question, and we'd like to address that as well. Okay, so this is the on-topic website. This is my email, and Diego, who is the responsible for the part of Bolzano, Diego Cavares. Thank you.
And the last one is Professor Riccardo Torlone from Roma 3, another winner of the academic cascade call.
Okay, thank you, everybody. This is a very brief presentation of this project that has been founded by the academic cascade call. It's a one-year project that started quite recently, and at the end of November, this is all the team involved in this project from Roma 3. But there is an ongoing collaboration also with people from Sapienza, in particular Antonella and Maurizio and their collaborators. The motivation for this project is basically the fact that AI, in particular deep learning, relies on the availability of a large amount of training data and, of course, training data of good quality. But this is quite a hard problem because it's quite difficult to find training data that is quite training data that is from real world applications. And a typical way to tackle this problem is to provide data augmentation techniques that basically, starting from some real data, generate further automatically further training data, but the data augmentation techniques are quite general, as quite hard to achieve, and so the problem of general techniques for data augmentation is a challenging problem, time-consuming problem. So the goal of the project is basically to provide external AI techniques for data augmentation, for the specific problem of data augmentation. The key idea is to build on our earlier research on data provenance and to provide methods and techniques for collecting data provenance for the specific case of data augmentation. And then to take advantage from explainable AI techniques to determine the training data that impact the model performance of machine learning models, and using these techniques to take advantage from the data lineage generated during the data augmentation process to identify points that, in general, to refine the data augmentation strategy and to improve the data augmentation strategy to produce better quality training data. This is a graphical representation of the problem we intend to tackle. Basically, we have different augmentation methods expressed by F1, F2 in this picture, and they produce different data training data sets, and of course different models that can provide different results on the same input data. And using these explainable techniques, we try to address the problem of how this model have been generated from a given data provenance, and training data, and from this going back to all the steps that have produced this training data with the augmentation methods, and take advantage from this knowledge to design a better data augmentation technique, data augmentation method. So these are the general projects goals of this project. Provide methods and techniques for supporting data augmentation strategies. And the approach is based on a model for data provenance that is specific for the case of data augmentation, and to integrate data provenance techniques with experimental AI solution to identify the sample of training data that more impact the result, the model we obtain. And of course, we plan to develop also experimental methods to show the effectiveness of the provided solutions. Again, building on our previous earlier research on data provenance, the main idea is to first of all provide a classification of all the data augmentation operators that are available in the literature, and to formalize basically a taxonomy of those operators. This classification can be done according to different perspectives, considering the kind of data augmentation methods and the kind of data that those methods work on, and using basically this taxonomy. The idea is to provide basically the patterns for data provenance for all of these classes, and then take advantage from explainable AI techniques that that fit well in this framework. Basically, the idea is to integrate explainable AI techniques with those methods for the collection of data provenance in the data augmentation process. Well, of course, we also plan to define a number of experiments, a number of evaluation criteria to guarantee the effectiveness and efficiency of our solutions.